Welcome to the live stream for the Falcon Heavy rocket, which is going to be launching today. It's launching a mission called SES O3b Power. I'm your host, Josiah. I'm a chief engineer at a student rocket group called ASTRA, and yeah, we are involved in building rockets specifically for in the amateur community and the student rocket community. But we like to take the opportunity to every once in a while stream an interesting launch, chat about some rocket science, and allow people to ask questions about what's going on at Astra and just general questions about rocketry. Uh, this is obviously a little enjoyable time that we can have here to learn, but also to see some cool things happen in the space industry. Of course, being students, we're having the ambition to participate in that industry very soon. So it's good to get an idea of what's out there. And also sometimes we get some ideas on how to solve some of our problems on the rockets that we build with some of the things that are happening in the industry. So sometimes it's good to pay close attention to what's going on. You might be able to use something like that. Hey guys, great to see you joining for this launch. It's going to be a nice one, especially if you're down in Florida or something. You might be able to actually catch a glimpse of this. It's always cool to see the Falcon Heavy launch because it's one of the most powerful rockets that it's available today. It's only the one notch behind the SLS vehicle, so it's the second most powerful rocket that's currently operating. So yeah, you might hear it, and if you're in the right spot, you might be able to see it too. So definitely keep an eye out for that. So the planned launch date or the planned launch time right now is in about 17 minutes. They have about a 1.5 hour launch window. So the launch window starts in 17 minutes, but they do have some opportunity for recycle or delay in the case that they don't have the perfect weather. They were supposed to fly yesterday, but they had some bad weather, so they had to delay till today. So hopefully the weather is a little bit more cooperative this time. Yeah, so we'll see how that goes. In the meantime, we can talk about some things about the Falcon Heavy rocket, but we can also talk about some things from Astra. So you have a question here. Do we bend PCB materials to do cylindrical patch antennas? Well, we actually did consider a cylindrical patch antenna. We kind of decided against it in the end, though, because it would be something that would be attached externally to the body of the rocket, and we didn't want to disturb the aerodynamics. Also, when we're our main goal is to build a rocket which will go to space, and when you're getting up to Mach 5, there's some questions about whether the antenna will actually do anything, because there'll kind of be a lot of interference with the shock wave and the heat around the nose cone. So we just have regular antennas that are on the inside of the nose cone, and we have one that's pointed up and one that's pointed down. So hopefully, regardless of the orientation of the vehicle, it should still deliver a signal. But we will be testing this on the smaller rocket that we're building called Karma. This is one we're going to launch in October. There's a European rocketry challenge called EUROC, where we're going to be able to hopefully test out some of the technology that we're going to put onto Transcendence, which is the rocket that we're going to try to send to space. But yeah, we'll see how that works out in the end. Yeah, as to why they didn't use the Falcon Heavy for the Orion capsule, to be honest, that probably would have been a smarter idea, because it actually does, for the mass restrictions and everything that they need, and how much delta V they need to get to where they want to go. The Falcon Heavy is totally capable of doing everything. There's one issue though, which is that the diameter of the body is actually smaller than the SLS. So there's some aerodynamic things that happen when you have a big fat thing on the top of your rocket, and then your core is skinny. So they would have to probably qualify that, and that would probably take time. They would have to do tests and a bunch of aerodynamic models and stuff. Of course, Orion is carrying people, so that's another whole level. The Falcon Heavy is not actually man-rated, So you can't actually fly people on the Falcon Heavy right now. And that would again be more effort that SpaceX would have to go through and NASA would have to go through to get the Falcon Heavy human rated. So I think that in the end, it was probably politics that drove it, because the SLS has a lot of political backing behind it. So it's tough to kind of put that kind of stuff away. But ultimately, it's good to have more vehicles. So it's nice that SLS is there. It's just kind of a bit expensive. I kind of have a comparison here for you. You can kind of see like the stats of the two vehicles compared against each other. So you can see, like, in terms of their payload delivery to low Earth orbit, like the Falcon Heavy can do 64 tons in expendable mode, and the SLS can do about 95 tons. But the difference comes on the cost, and you can see that obviously the Falcon Heavy is like a 20th the cost of an SLS. So like if you were in a world of like supply and demand economics, obviously you'd fly on a Falcon Heavy or try to get the Falcon Heavy human rated and try to make it work with the aerodynamics. But there's other things that come into this. So yeah, it's a complicated world when you get the politics involved. But yeah, it's one interesting thing about today is that the Falcon Heavy will not actually be flying in the recoverable mode. They're actually going to be flying in the expendable mode. So we're not going to get to see those two rocket boosters come back and land at Cape Canaveral. They're just going to be crashing into the ocean. The reason for this is that the payload, so the people that are paying for the payload of the rocket, they paid SpaceX extra money so that they could fly this thing with all of the delta V that it possibly can give. Basically, they're trying to insert it directly into geostationary orbit. Usually they go into like an elliptical orbit. Like that's how rocket vehicles send payloads up to geostationary. They put them into this elliptical transfer orbit, and then the payload has to circularize itself, which costs it a couple thousand meters per second of delta V. But the Falcon Heavy is so powerful, it can just take satellites all the way straight to geostationary orbit all by itself. So that's kind of what they're trying to do here. But because of how massive the payload is, they have to expend the boosters, unfortunately. Yeah, more about why we rejected the cylindrical patch antenna. Again, the main thing was the fact that you were going to get crazy high heating on the outside of the rocket vehicle. So our initial simulations have the outside temperature of like the skin around the nose cone reaching temperatures on the order of 500 to 700 degrees Celsius. So I'm not sure that the antennas can survive that thermal environment. So in the end, we'd have to put them inside anyway, or put some sort of insulation over top of them. And at that point, it kind of seemed like it's too complicated to deal with that and have that be a reliable method of communication. Keep in mind that we are new to the antenna business, so we might be wrong, and maybe we find out in our first rocket launch that our current solution is a bad idea and we have to switch to the cylindrical antennas. But yeah, putting an antenna on the outside is something we decided against, essentially, mainly because of thermal reasons and aerodynamic reasons. Mach 5 is a very extreme environment. Keep that in mind. There was a mission today. It was earlier today. I think there was like a Starlink launch or something. It was with the Falcon 9. Oh yeah, the ViaSat ones. Correct. Yeah, that's right. So yeah, the Falcon vehicles are launching a lot lately. We also just recently had the test of the Starship vehicle. That was only a couple days ago, or a week ago, I guess. So yeah, SpaceX is quite busy these days. Yeah, I guess it's at different times for different people in the world. But for me, it was today. So unfortunately, I didn't quite get to see it. We were working on the rocket, so yeah, plugging away trying to solve our tank issues because we're trying to build an oxidizer tank, and so basically building out of carbon fiber is not easy, and we failed a couple of times now, and we're trying to work out the issues with that. But yeah, we'll see. Do we use FPGA? I am not sure about that. I think we do, but I can't guarantee that. I would have to talk to the avionics guys again. Let's quickly jump onto the live. I think the live might have started. No, it's not started yet. Never mind. Okay, it might be a bit longer for the launch if they haven't started the live stream yet. Oh, we'll see. We'll keep checking back. Yeah. We also do have an antenna on the GPS that's going to be, this is the one that we're struggling. We're probably going to struggle with the most, is trying to get the GPS antenna locking into satellites reliably. So we have there as well. We're going to have actually two GPSs, one that's going to be pointing up and one that's going to be pointing down again, just to try to make sure that we can get a GPS lock at all points during the flight. So yeah, that's another thing we're going to be testing with the Karma vehicle. Let's see if that's possible. Regardless, though, we will still have struggles with GPS when we fly Transcendence, because it's going over 50 kilometers, and there's like a whole bunch of restrictions around getting GPS data beyond that point, because basically the US government thinks you're a missile at that point and then shuts down GPS access. Yeah, we can talk about Starship. Unfortunately, we didn't get to stream that launch because we were hard at work in the lab making more carbon fiber tubes. But it was a very interesting launch. You could see that the vehicle performed okay, I guess. It didn't perform great. Like, you saw lots of engine failures at the start of the mission. You also saw that they completely destroyed the launch pad. Like, I have no idea why they decided to launch without a flame diverter, like that usually takes the flame and diverts it away from the launch pad. You see this at French Guiana, where they launch in Kourou, the Ariane 5. This is like typical for big rockets, is that you have a flame diverter, but for some reason they decided not to build one for that, and yeah, they suffered the consequences. There was debris from the launch that was successful, that didn't blow up. Like, debris went for like kilometers away from the launch pad. But yeah, I mean, ultimately it actually flew a lot more successfully than I was expecting, because like they got the thing off the pad, it flew up, it lost some engines, so it couldn't quite get to the performance that it needed for that first stage. But clearly you could see that they are able to handle a lot of engine outs and still fly. Clearly it was a matter of just the aerodynamics overcoming them, though, because you saw the engines kind of all went out on one side of the vehicle. So at a certain point, their gimbal range becomes an issue, and because they are flying a vehicle that kind of has a bunch of aerodynamic surfaces on the top, it's aerodynamically unstable. So as they get to that max Q point, and in those places of high Gs, you essentially have the issue that the vehicle fails structurally because of the angle of attack that it has to the wind. So yeah, not crazy, unexpected that happened given the circumstances, and I think that these are problems that they can easily work out. So I'm not really too worried. They will take some time to get the pad back up and running, so I don't expect to see another launch of Starship probably for another like 9 months to a year. But yeah, depending on how fast they get that spun up again. When do we think the Ariane 6 will launch? That's like looking into the crystal ball. They say it's going to launch by the end of this year, but I think that that's probably ambitious. In reality, I think it'll be 2024 when they finally get it off the pad. Just because, I feel like they're always delaying. So I think by 2024 it'll finally be imminent, and they have to get it launched. Otherwise, the company's in danger because the Ariane 5 is retiring. So Ariane 6 has to come, right? Otherwise, they can't fly payloads. Yeah. Okay, SpaceX is still not up yet. Yeah, I don't know if the nose cone was pointier, it would help the aerodynamics. That's true. On ascent, it does help the aerodynamics. On descent, it doesn't, because you want a blunt body as you come back from space. But obviously, when you're going up, pointy is better. But I think the main drawback the Starship has is those are like the little flap things it has on the back. Like, they are really positioned in a bad spot for a rocket, and they cause you to have to really gimbal those engines in order to keep the rocket flying straight. Basically, if it didn't have gimbling engines, the rocket wouldn't fly straight. It would literally spin end over end, because it wouldn't be aerodynamically stable. So it was definitely a challenging environment that it had to fly in. Yeah, I suspect they'll figure it out though. Like, it shouldn't take them that much. But yeah, we'll see. I'm looking forward to their next launch. I think the next one's going to be a lot more clean, because now they've learned they've learned the things that they had to learn on that first test. Basically, there's a couple things. First, flame diverter. They got to beef up the pad, make sure that it can withstand the force of the Starship, especially because it's going to land there again. So it has to be able to handle multiple firings per day. They need to make sure those Raptors are more reliable, because 5 going out immediately is not a good start. Like, they barely got off the pad. Like, if 2 more engines had failed, they would have not had enough thrust to weight to go vertical, and that would have been a much more explosive situation. So they have to get the Raptor more reliable, and I think they have to do a little bit more in terms of the flexibility that they have in terms of aerodynamic stability. So I don't know if they need more gimbaling engines, or maybe just a way that they can turn off engines in case some fail on one side. They should turn off the one on the other side, because otherwise they're giving themselves too much off-center thrust and making their problem worse with the aerodynamic instability as well. Of course, you would need to have a more reliable Raptor for that to work, because if you shut down more engines, then you're back in the thrust to weight issue. When are we buying APCP? Okay, well, we're never buying APCP. We're not building solid rockets, so yeah, you definitely can't buy that in Germany, not without being a licensed explosive expert. So you need to have a special license that says that you are qualified and allowed to operate with explosive materials, and only then can you buy oxidizers like that. And that process can take 5 years for you to get that clearance, and you have to go through trainings, you have to take tests, you have to prove that you are qualified to be able to work with those types of things. Something definitely that you couldn't really do as a student group. It'd be very difficult anyway. So that's why one of the reasons why we choose to build hybrid systems is because that's what allows us to actually build the rockets and have all the things that we need to actually get clearance and stuff. Even just getting nitrous oxide in Germany, that's hard enough. But it's easier than the APCP. So yeah. In terms of other things, for starting our rocket, we need a little bit of solid propellant. And for that, we're just buying commercial ETSI's motors. So just the little ones you put into the little rockets. And we just basically stack a bunch of them together and use an electronic igniter, and then that's what starts the rocket. So that's the only place where we really use solids. And those, of course, are legal as long as you're over 18 in Germany. So we kind of work within those parameters. Yeah, licenses suck, but that's the way it works in Europe, unfortunately. I guess in America it's a little easier. But even APCP would be difficult, especially if you want 100 kilograms. That's a lot, man. What are you doing with 100 kilograms of that? That's definitely a vehicle that could go to space. Yeah, good to have you, space guy. Hopefully we get to see a launch today. Please ignore the clock at the bottom. It's no longer relevant. SpaceX is definitely delaying this launch a little bit. They do have a launch window, so they can start the launch. They have basically 80 minutes. 80 minutes, I think. Yeah, it must be 80 minutes. They have 80 minutes for where they can launch this rocket, starting from basically in a minute, and they could launch at any point in that time. So we just kind of have to wait to see when their stream starts, and then essentially they'll be going in about 10 minutes after that. I think maybe we should just get rid of the clock here, as it is no longer really relevant. There we go. The rocket is launching when it decides to launch. Yeah, you better not tell me what you're going to do with 100 kilograms of APCP. I'll be part of the plot then, huh? Could ammonium sulfate be an oxidizer? I don't know. Sulfates usually aren't oxidizers, are they? I'm not sure that would work. You could use ammonium sulfate to make ammonium chlorate. That would be an oxidizer. Or ammonium nitrate. I think ammonium sulfate can be used. I'm not sure if it's as effective though as ammonium nitrate. That's a good question. I don't know. If you do try, let me know if it works or not. I don't know what the ratios to use would be. I think you have to do some stoichiometry to figure out what you're gonna burn that with and how you would use it. Also, remember that you have to be able to mix it in a safe way in a binder. So make sure you understand that process as well, because you don't want to do it unsafely. That would be not a good time. So definitely do a little more research on that before you start playing around with it. Yeah, I don't know. 100 kilograms of APCP would definitely be enough to blow up the Falcon Heavy, that's for sure. But why would you do that? Come on. What did it ever do to you? Yeah, so we do use graphite for our nozzles. Actually, we have a video coming out relatively soon on our nozzle and our nozzle design, so watch out for that. It's going to explain everything about what we're doing. We've actually tried a couple of things. So we built one nozzle completely out of graphite. So it's basically like we had a block of graphite and we got a company to machine it down to look like a divergent nozzle. That is expensive. So we don't really want to do that, because that much graphite and then machining it, in the end it cost us like 500 euros. So we decided to try casting a nozzle out of aluminum bronze, and then insulating it with like hard paper and phenolic resin. And then we have a graphite insert that goes into the middle that kind of insulates the throat where you get the highest heating. And that will basically ablate. So we're kind of using a bunch of things. We're using bronze, we're using the hard paper, phenolic resin insulation, and we're using the graphite. And the beauty of that is that we can make all of that ourselves. And in the end, like, the raw material for the nozzle ends up only being like, 30 euros or so. It just takes a lot of time, but we're students, we have time, we don't have money, so it all works out in the end. Yeah, but if you want to know more about that process and how we're doing it and how it's kind of all working, I think the video will come out in roughly 2 weeks, so then you'll get to see all about how we did that. Yeah, I don't know if sulfates are that effective at being oxidizers, but you have to definitely do the chemistry first. It's not something you can just look up because it's the less common oxidizer type. So you probably don't, it'll probably be more difficult to find like anecdotal data for how to do it properly. So you might have to break out the stoichiometry to figure it out. Yeah. But yeah, I know ammonium nitrate works great, so you can definitely get a lot of kick out of that. Yeah. Do we have any access to hydrogen, to hexogen RDX? What the heck is that? For example, if rocket is uncontrollable and you want to blow it in the air. Oh. Yeah. Okay. So I'm assuming this is some sort of flight termination system type of hardware you would be using. I don't know what hexogen RDX is though. We definitely we might have access to it, but I wouldn't know because we've never tried. We're not putting a flight termination system onto the rocket. It's a passive stabilization system. So basically, once you light it, it just goes wherever it points. It can't really do anything else. So it can't really get quote unquote uncontrollable. It's never controllable, so it's always just passively controlled. Now, granted, we could like lose a fin or something, and then it's no longer like going the way you expected. It'll do some weird action. But I guess for amateur rocket level, you don't usually attach a flight termination system to the rocket because it's just a bit unnecessary. Also, I think the flight termination system would be more dangerous than the actual rocket itself because, like, the flight termination system could have something that goes wrong and could blow up, unexpectedly at any time, and that's also a danger. So you have to kind of weigh the fact like the what's the chance that the thing will, fly outside of the safety area versus the chance that you will, mess up with the flight termination system and accidentally blow yourself up. And for most amateur purposes, I think that the risk is much higher on the, trying to figure out how to make a flight termination system work versus, not staying inside the safety area. Okay, hexogen is one of the most powerful blasting explosives. Okay. I think we don't have access to that. Based on my knowledge of the German laws, I'm going to say no. Yeah, definitely if it's a military thing, that's definitely not something student groups in Germany are going to have access to. Do you have access to that? I mean, my goodness. I feel like that would be a bit dangerous to work with. All right, I'm not sure exactly what's going on with the Falcon Heavy here. Let's check Twitter. Maybe they're saying something. Let's see here. Wait, am I not signed in right now? Okay, I'm not sure. Have they said anything on the live stream? We do have to keep in mind that they do have a launch window. So it is an 80-minute launch window. It started about 10 minutes ago. So they still have 70 more minutes in which a launch could occur. So keep that in mind. Basically, when we see the live stream go up, we'll know that they're ready to launch. But I'm not sure how the weather is there. Maybe are they waiting for weather? I'm not sure. Unknown. They say it's 70% favorable for the launch window today. But I'm not sure. But that was an hour ago. It's unclear whether that's still the case. Yeah, okay. I didn't know that you could. Okay, wait. In Poland, you can buy a micro hybrid that's Class E. I didn't know this. That sounds awesome. And you're just using the whipped cream cartridge for the nitrous oxide. That's actually pretty interesting. That's cool. How do they ignite it? Like, do they just use? They must have some sort of like built-in spark thing, or what? Is it just the same way you light solids with the electrical igniter? It seems like it would be a bit more difficult to ignite than a normal solid. Okay. Yeah, I guess Emmett, you probably need a VPN with all the stuff you're searching. Yeah. Although I'm probably on a watch list as well, so I'm buying all kinds of weird stuff. Yeah, unfortunately, SpaceX is not updating their Twitter. It's still just their post from an hour ago, so I don't know what the deal is with the launch today. The live stream is just waiting, so I assume that they're still planning to launch today, but we're just looking for a better part of the window. The window is about an hour more, and then just over an hour more, and then they would have to delay until tomorrow. Okay, so basically they ignite it just by opening they burn a hole through the cartridge, and that heat is what ignites the rocket itself and kind of starts it up. That's interesting. Huh. I have to, maybe I can think about getting one of those and seeing how they work. It looks kind of cool. I wonder if it's as reliable as the solid rockets. Yeah, no problem. Happy to entertain where we can. But hopefully we still get to see a rocket launch today. I'm not giving up hope just yet. If there is an issue, it's probably because of the weather. Because they were 70% on weather, so it could be that they're just waiting for a better weather opportunity in the weather window, in the window they have. Yeah. Yeah, okay. Wait, you got frostbite? Dude, what were you doing? How did you get frostbite? Were you messing around with nitrogen or something? How did you get frostbite? You must have been playing with nitrogen or something. Or else you live in like Norway. That's my only thought. uh Okay, yeah, I'm definitely gonna check out this micro hybrid thing. I'm very curious about how this works. It looks cool, and maybe it'll teach us some things about how to ignite our own rocket. This is still a bit of a black box mystery for Astra. We're not really sure exactly if our ignition solution is going to work or not. It's kind of tough to test because, like, you can light your igniter and stuff, but unless you actually, blast your expected flow rate of nitrous oxide into the combustion chamber and see it ignition, you don't really know if it's working or not. So basically, we're not going to know until we go to the test site at the end of May and do our static fire testing. Yeah, Xerxes was at the South Pole. He's at the South Pole, man. Okay. Yeah, you can get frostbite at the South Pole, that's for sure. Okay, so you were messing with some sort of very cold gas. All right. It all makes sense. Yeah. Uh, yeah, that could have been a lot worse. Minus 55 is pretty serious. Although I have to say, I have been outside in minus 45. I'm from Canada, so sometimes you get some really bad days. Uh, but yeah, that's definitely extreme. Yeah, well, maybe next time some gloves might be helpful. So we're still waiting on the potential opening of the launch for the Falcon Heavy. Uh, yeah, not sure if it will actually fly today, but they do have a launch window, which is an hour and a half long. So far, we're about 20 minutes into that launch window. The SpaceX stream is still not started, so it's unclear as to what exactly is happening. I also don't think they've made an update on Twitter yet. We just have their one update from an hour ago saying that they're 70% on weather. And I'm not seeing anything else. Yeah, they do say though that the weather does improve towards the end of the launch window, so we should expect to see them having an improving weather situation at the end. So it could be that they're just waiting until the very end of the launch window. That could be possible as well. So it'll be one of those things where we have to hang on to our seats for the next little while, and hopefully it'll pay off with the rocket launch at the end. We'll see. What's the cargo? Yeah, so the cargo is apparently not what is on the SpaceX stream. It says that it's the SES O3b mPOWER mission, and that's what I put into the title of the video. But I think it's actually the ViaSat-3 Americas mission. So yeah, the SES one is a communication satellite, but the ViaSat Americans mission is one that's going into geostationary orbit. The other one just goes into a medium. It's like a medium orbit. I don't even know how do they call it. It's not low Earth orbit. It's not geostationary orbit. It's like a medium orbit. But I'm not exactly sure what the ViaSat mission is about. Let's check. Let's check what it's up, what it's about. It's a commercial payload, so it's not like a military thing. It's not like a spy thing. As far as I know, it's a communication satellite. So, like most satellites that go up to geostationary orbit are communication satellites. So it's like a good spot to communicate because you're in orbit around the Earth where you stay in a fixed location. Because the orbital like speed is the same as the speed that the Earth rotates. So most of the satellites up there are just doing like communication. The spy satellites usually go into low Earth orbit because you want to be as close to the Earth as possible so that you can, use your telescope to zoom in on stuff. You couldn't really do that from geostationary orbit because, you're really far away. Yeah, Elon doesn't build single-use rockets. He builds single-use launch pads. Yeah, I think that's very true in the case of Starship. But I think they learned their lesson. I think they're gonna build a better launch pad this time. Is there a barometer that can handle 100 kilometers altitude? I'm gonna say no. Not one you could stick into a rocket easily. Like think about it, right? The barometer is measuring air pressure, and the air pressure is decaying exponentially as you go up into the atmosphere. So by the time you get to 100 kilometers, like there is so little atmosphere that the difference between like 98 kilometers and 100 kilometers in terms of the air pressure is going to be like something times 10 to the negative 100. Or sorry, not that bad. Times 10 to the negative 10 or something. And your barometer is not going to have the resolution to pick that up. Like especially if it's like a digital barometer, like the step size of the actual sensor reading it will not be able to have the resolution to give you a accurate altitude. Like you'll get accurate altitude data out of a barometer probably up to 30 kilometers or so, but beyond that it's going to get really bad unless you have like some crazy precise barometer on board. But if you have that, it's probably massive like compared to the flight hardware of everything else. So better just to use something else to calculate altitude, I would say, unless you're trying to test the how good your barometer is. Maybe you're like a weather person and you want to get some very accurate pressure information about the atmosphere. Could be the case. Then it would be like a special payload. Have I heard of the North Korean space program? I don't think they've ever gotten anything into space, have they? I think they just have a missile program. Has North Korea gotten anything into space? I don't think so. Not that I'm aware of. They're not listed as a space capable country yet. They did? What did they get into space? I know that they've launched things high enough to be in space temporarily, but have they actually gotten into orbit before? I don't think they have. Not that I'm aware of anyway. Maybe I could be wrong about this. If they did, please let me know. What was the mission? Or is it like a on the down low? Like they they did it but in the secret way. Yeah, I don't know. I don't think they've actually gotten anything into orbit yet. There's only like a couple of countries that have done it. Like it's America, Russia, China, India. Great Britain got one into orbit, but then they decided not to do it anymore. Of course, Europe does it with the Ariane 5. I can't really assign that to any one European country. Maybe it's mostly the efforts of, France, Germany, and Spain. I think Spain's part of the Ariane group. Don't quote me on that. Yeah, negative pressure is, I guess, not a thing. It would be like negative energy. It's like negative energy. If you have a system where you can have negative energy, then you could have negative pressure. And negative pressure actually is a thing. Like pressure pushes, where negative pressure like pulls, I guess. If you look at like a siphon, like the water that's being sucked out of the siphon is usually represented as being at a negative pressure. So you can have negative pressure. Or is that just vacuum? I don't know. This is actually an interesting question, because if you actually look at how there's been some YouTube videos on this. Like if you look at how a tree works, right? It has, leaves that are way up, like 50, 60, 70 meters tall. So how does the water get from the ground all the way up to the leaves? Like if you go by basic, like if they had a complete vacuum inside of the tubes that the tree is using to get the water up, it can only get the water up like 10 meters. But clearly the water is going all the way up to the top of the tree. So there must be some like bigger force that's pushing the water all the way up. Well, what's actually happening is that there's actually negative pressure acting on the water in the tubes that go up the tree. And that's what's pulling the water up. So you can have negative pressure. That's the thing. I'm not really sure if it's good to think about it in terms of being a negative, though. Like from a physics point of view. I don't know. It's confusing. I'm not a biologist. Okay, so they do have 2 satellites in orbit. Okay. But did they launch it on their launch vehicle, or did they launch it with somebody else? Because I don't think it counts if you didn't launch it on your own launcher. I don't think you can count that. Yeah, capillary reaction. That's what I was trying to say. But yeah, you can get kind of like a negative pressure with capillary reaction. Okay, so they did do it with their own booster. Okay. If it was their own booster, then I guess it counts. Okay, we have to add North Korea then to the list of space-capable countries today. Although, to be honest, I don't think they really have the resources to like contribute meaningfully at this point. But who knows? A lot of their stuff is kind of, on the down low. They don't really publicize, their launches and stuff like everyone else does. Their deep space exploration program. Okay. So I have to assume they went past low Earth orbit then if they have a deep space exploration program. I think that's the definition. I'm pretty sure that we use FR4. We use whatever the cheapest thing is. Like we just we get the PCBs like made specifically for us by some place probably in China. Like the cheapest thing that's available. So yeah, nothing too fancy. and I would recommend that if you're just starting up with rockets, that you go with the cheapest stuff anyway, because like better to learn a little bit on things that are less expensive than mess up with expensive stuff. We've fried a couple PCBs already, and we've designed some of them wrong. So yeah, it's good that we're doing it the cheap way. Now I feel like you're just making up North Korean programs. I feel like they have like mainly one mission for their rockets and space programs in general, which is prove that we can launch nuclear weapons around the world. It's on the Wikipedia. Maybe they're editing the Wikipedia. They've got a lock on the information. Maybe it's not the best place to be going for the data. All right, for those just joining, we are still waiting for the Falcon Heavy launch today. We're not sure exactly when it's going to launch. We do know that they had a launch window that started 30 minutes ago, and that launch window extends for an hour and a half. So we still have an hour left for which we could see a rocket launch. We do know that the weather was about 50-50 at the start of the window, but was about 70-30 at the end. So it could be that SpaceX is just waiting until the end of the launch window to try to launch the Falcon Heavy when they expect to have some better weather. And they won't start their live stream until they're basically ready to launch. But it could be that they decide that they're going to scrub today. They do have a recycle opportunity tomorrow at the same time. So that also is still available to them. But we are still going to stick around until we get confirmation from them. It could be that we still see a rocket launch. So don't give up on today's possible launch yet. I think that would be premature. It looks like they just updated saying that the clock is now going to be 6:12 Eastern, which is, I believe, in 27 minutes. So we're now 27 minutes away. Yeah, it looks like it's going to be 27 minutes away now. All right. So we're not done yet, guys. It could still come. Yeah, I had no idea that North Korea had such high space ambitions. I feel like they just want to do everything that everyone else has done. My goodness. Yeah, have any of you seen For All Mankind? Because I think there's like in the third season or something, there's a North Korean that actually gets to Mars first. Sorry if I'm spoiling that. It's been on the air for a couple of years. I feel like that's not a spoiler at this point. Yeah, maybe North Korea has a huge space program that we just don't know about. It's all secret. All right, maybe I can start the clock again. Let's see. Maybe I can fit. How do I reset this clock here? Okay, so we said that we're going to be going at 6:12 Eastern, and that's in roughly 24 minutes. Okay, so let's put the clock back up. All right, so now we're counting down. 22 minutes. Hopefully we will get to see a launch. Wait, did I do this right? No, it should be in 25 minutes. Sorry, technical difficulties. Let's start that again. Okay, we should be back on track. So in 24 minutes, we have the expected launch of the Falcon Heavy, according to the latest Twitter from SpaceX. And it looks like they're just trying to get basically right to the end of the launch window because they want to take advantage of the better weather that they're expecting at that point. So hopefully nothing else will get in the way of this thing. All right. I'm a little more confident now that it might go today because, yeah, we could. They've now kind of set a time that they expect to do it. So, and we're within the 30-minute window of it. Wait, is the Falcon 9 going right now? Is that what's happening? Are they that close? Oh yeah, you're right. It is the Falcon 9. Okay, well we have 2 launches today. One of them is the Falcon 9, and one of them is the Falcon Heavy. Okay, I apologize for that. Yeah, the Falcon... Sorry, I'm confusing people. The Falcon Heavy is flying in an hour and a half, or 2 hours. Hour and a half? Let me check. Yeah, it's the Falcon Heavy will fly in about an hour and a half. The Falcon 9 is flying in about, what's on the clock there? 22 minutes. So we're hopefully going to get to see both of them. But, you know, at a minimum, we'll at least get to see one. Yeah, so, yeah, you'll be asleep by then. Well, we'll miss you. I should probably be asleep as well. It'll be like 1:30 by the time the Falcon Heavy is supposed to go, so yeah. But just to clarify, the Falcon 9 is going to be launching the SES O3b satellite. This is a communication satellite, which is going into medium Earth orbit. So it's kind of like that place where a lot of the the GPS satellites are. So similar kind of satellite as that. The one that Falcon Heavy is launching is the ViaSat satellite, and that is going all the way into geostationary orbit. And that's going to be one that the Falcon Heavy launches, and it's going to launch it directly there. Like, it's not even going to put it into the transfer orbit. It's going to take it all the way. So that'll be a bit interesting. You stayed up to 5 a.m. once. Yeah, well, you know, one of the things that ASTRA has gotten used to is pulling the all-nighter. So, yeah, I've pulled a couple too many of those this year, to be honest. But yeah, if everything goes well, we should see the doubleheader, and we should get to see both rocket launches. So, yeah, we'll see how that goes. For now, we're waiting 20 minutes until we get to see the Falcon 9 launch. And we're about an hour and a half away from the Falcon Heavy. So, yeah, should be an interesting night. What's really cool, though, and I don't know if this is actually something that's even possible, but Apparently, it's the way it's scheduled right now. Both of these rockets are actually launching from Cape Canaveral. So, like, they're within an hour of each other, and they're both going to launch from Cape Canaveral, which means that they're going to like recycle the area, so to speak, in quotation marks, in such a tight like time frame. I don't think that's ever happened before in that way. Like, that's quite unusual. So I hope that it all works out, but maybe we'll be able to see like the Falcon Heavy just like from the view of the Falcon 9, just like in the distance, also being set up, getting ready to fly. Could be an interesting pair up. All right, we're getting closer. We should see the SpaceX stream starting up any time now. Not really sure exactly when they're gonna start that up. It'll probably be about 15 minutes before the live cast. Usually that's their typical behavior with that. In the meantime, we can talk a little bit about the recovery features, although I'm not sure that's really relevant in this case, because I think they're going to actually be expending. They're not going to be. They're going to be recovering this core on just read the instructions, which is the drone ship that's out in the ocean. So let's just talk a little bit about the recovery features that it has, in case we have forgotten. So basically here we have like a diagram of kind of how the Falcon 9 is going to reuse itself. Of course, we have the grid fins, which are at the top, and those are going to extend after it has launched. And then those are going to help it navigate back to the drone ship when we're back into the atmosphere. We also have cold thruster packs, which are up near the grid fins as well. And you'll see puffs of smoke as it's flying on its own, as it comes back to the drone ship. That is basically the way that it maneuvers itself in space, because of course there's no air, so the grid fins don't really work there. And then of course it also has the gimbaling engine, which allows it to maneuver when the engine's on, and it's also going to use that engine to actually create kind of like a force field around the body of the vehicle when it's coming back into the atmosphere. So it should experience less heating because of that. And this is kind of like the secret sauce to how SpaceX is able to recover their rocket boosters. And then of course we have the landing legs, which will open up just before it lands onto the drone ship. So hopefully we'll get to see all of that action in this launch. Yeah, make sure you get to the hospital. I guess I assume it's still about the frostbite. You definitely want to make sure you take care of that properly, because that can be real nasty. Yeah. As a Canadian, I can attest to that. Have we ever used jet vanes? No, we have not played around with this yet. This is something I think that, yeah, with jet vanes, like you would need to have a ceramic essentially, like for the types of rockets that we're building right now. Like we're building kind of like a high power rocket. So if we use a jet vane, like we have to be able to withstand basically like 2000 Kelvin. So doing it with metal would be very difficult. The problem with this whole idea with the jet vane, yes, you can use it to help gimbal your thrust, and maybe control on off if you like have the vanes like close up or something. But the question is, why do you want to do that? I guess you can use it to try to control the trajectory of the vehicle. But usually if you do that, then you have to worry about a bunch of regulatory issues, because now you're no longer a ballistic vehicle, you're now a guided vehicle. And this creates a whole bunch of issues with launching. So we're trying to, for the first rockets, start with the simple stuff. Yeah. If you're dealing with smaller rockets, like, you know, hobby class rockets, I think that the jet vane is maybe more interesting, because you have the leisure to be able to play around with that without running into the regulatory issues. But at the high power rocketry level, I think it's a lot more difficult. Yeah, if anything goes wrong, you're kind of in the shit really quick, so to say. Yeah, you got it right. The Falcon Heavy will expend all 3 cores later, which kind of sucks. But they need it to get that ViaSat all the way into geostationary orbit. It's the direct insertion. So they're paying more for it. So you got to give them what they want. Yeah, let's switch over to the SpaceX live stream. Okay, wow. All right, here we go. So they should start up with showing us what's going on there in a couple minutes here. We are just 12 minutes away from the launch. At least the latest launch time that they gave to us. So looking forward to seeing if this will go. Yeah, I think that if you look at the complexity that it takes to build jet vanes versus just gimbaling the engine, I feel like you can just gimbal the engine. Like, the vane is adding this extra thermal complexity that you don't really need to have, if you know what I mean. Like, why not just gimbal the engine itself? That's a good point. If you're launching from a tube, you can't use fins. That is true. I don't think I've ever seen an amateur rocket that launched from a tube, though. That's not a typical way to do it. But yeah, if you were going from a tube, you definitely need to have some sort of thrust gimbaling, because there's no other way to really control ballistically than that. What's the significance of this launch? Well, there's no significance to this launch that's coming up just now, except, you know, if you are, you know, working with the SES O3b power mission, it's significant to you. What's interesting, though, is that we're going to get to see two for the price of one here. So we have this launch that's coming up in just a couple of minutes, and then in an hour, just over an hour, we hopefully will get to see the Falcon Heavy launch. And they're both launching from the Kennedy Space Center there. So we might get to see both.
The mPOWER mission for our customer SES. On your screen is a live view of Falcon 9 awaiting its 6:12 p.m. Eastern Time launch from Space Launch Complex 40 at Cape Canaveral Space Force Station.
And yes, ballistic rockets are our final goal. Like, we're not interested in making a guided rocket at this point. That's something that we would be looking for in the future, potentially. But first we have to figure out the ballistic rocket, I would say.
With the potential of a third of our Falcon Heavy vehicle awaiting liftoff at our neighboring pad in just over an hour from now, as long as weather cooperates. Now, some of our longtime viewers might know that SES was one of SpaceX's earliest launch customers and has been a key partner in a number of firsts with us. SES was the first commercial satellite operator to launch on Falcon 9 from the Cape back in December of 2013, and the first customer to fly on a flight-proven booster on March of 2017. Today's launch will mark the second of 5 total O3b mPOWER launches. We launched the first 2 O3b mPOWER spacecraft in December of last year, and today we will be launching 2 additional O3b mPOWER spacecraft into space. Now, SES's O3b mPOWER system will operate from medium Earth orbit, or MEO, and comprises an initial constellation of 11 high-throughput and low-latency satellites, as well as an extensive ground infrastructure. Collaboratively designed with Boeing, the O3b mPOWER is SES's second-generation MEO system. And with that, here's a video sharing a bit more about our mission today.
Yeah, the foldable wings are not a terrible idea, but there's definitely a lot that could go wrong with that if you're using that as your tube launch concept. So I would just fear for that, because if something went wrong with the foldable wing, you could be in some pretty serious trouble. I know that some drones launch that way these days. Like they launch from a tube and then they like fold out their wings and fly away. But yeah, that's definitely getting complex for a student rocket, I would say. Remember that, like, when you're thinking about how to design around doing things as a student group, like, you have to think about the complexity of what you're doing. Because the things that are going to stop you from being able to execute a concept are, number one, cost. So sometimes it will cost you more to be able to do a more complex topic or a more complex concept. And that can really hold you back. But the second part, and maybe the more important part, is actually the time. Because, people have to ultimately execute this. And usually when you're in the amateur sphere, it's either just you or it's you and maybe a group of other people. But you don't have infinite resources in terms of time. Like, you're a human, you have limited by your lifespan. And getting a complex thing, like a bunch of complex things to work all at once, drastically increases the amount of time it takes to do it. And usually that will deter you from getting too complex. And to be completely honest, in general, you should try to navigate towards the simplest thing possible, because that's the one that has the least failure modes and will give you the most reliable solution at the end. Unless there's a specific reason as to why you're trying to make more complexity, like maybe there's a functionality that you want to have that can't be had unless you do this complex thing, it's not a good idea to pursue that. I think the SpaceX kind of adopts this philosophy as well. So look out for their design choices. Usually they have this in mind.
It'll hold just over 1 million pounds of propellant that the vehicle will burn through in less than 3 minutes after liftoff. We began loading those propellants on both stages at about T-minus 35 minutes. Now, starting from the very top of the rocket, our payload today is safely enclosed inside of the 17-foot diameter payload fairing, which is that structure at the very top of the rocket. It's made out of a carbon composite material. The fairing protects satellites on their way to orbit, and the fairing halves will be jettisoned approximately 3 minutes into flight. Now, for today's mission, we have 2 spacecraft on the second stage and inside the fairing. Each payload will deploy at separate times, about 6 minutes apart from each other. And the fairing halves supporting today's mission are flight proven, with one half flying for its 3rd time and the other half flying for its 4th time. Now, just below the payload fairing, we have the second stage that will take the O3b mPOWER payload to space. The second stage will ignite its single Merlin vacuum or MVAC engine about 2.5 minutes into flight, and then relight for a 2nd and 3rd time before we deploy the 2 satellites. Below the second stage, we have the inner stage, which is a part of the first stage. And as you can see on your screen, the carbon fiber inner stage has a distinct black color because it is unpainted TPS, or thermal protection system, and it protects the composite material of the inner stage. Now, at the bottom of the first stage, there are 9 Merlin engines that will get the Falcon 9 off the ground and up into the thinner parts of the Earth's atmosphere. Shortly after liftoff, the first and second stages will separate from one another. Then the second stage will continue to orbit, while the first stage will start making its way back down to Earth. The first stage is designed to be reflown with...
So that's a good question. What the hell is Blue Origin doing? To be completely honest, I would say that they are a lot more behind in terms of the technology of building a launcher. They haven't built anything yet except for their demonstrator rocket, which is the New Shepard vehicle. That has proven to be quite useful and reliable for the functionality that they want to use with it. But I don't think we'll see a Blue Origin rocket hitting the skies probably for another 5 years or so, to be completely honest. Now, I could be wrong. New Glenn is always scheduled to be launching, within the year, but it keeps getting pushed back. The reality is that their engines are not really ready yet, and in terms of the whole process of developing the vehicle and all the complexity, I don't think that they're actually going to be in a place where they're going to be able to launch in the near future. So I wouldn't expect them to be in a place where they can do that for a little while longer. Blue Origin operates kind of more as like a research group, kind of in a way. Like they don't really do a lot of actual building of the rockets. They're kind of more in the let's think about the problem and come up with some ideas and run those ideas around and test some rockets or something. But they haven't really gotten to the phase where they're like, okay, let's actually go and build a rocket and have it fly. They have kind of a very different philosophy than SpaceX. SpaceX is like, okay, let's build it and see what happens and learn and build some more stuff. And then, we'll get ourselves towards the right solution by, failure, trial and error. Blue Origin goes the other way and says, okay, let's make sure that everything will work 100%. And it's like they design. And then by the time they get to actually building it, they've perfected the design in their mind, right? Personally, I think that the better strategy is actually to go the SpaceX way, which is, build stuff and launch lots and learn quickly. Usually that is a more effective strategy where you have lots of new stuff you're trying to do, because, you can do all the research you want. You're not going to see the things that you're going to see when you actually put the rocket on the launch pad. So
weather is currently a watch item, but we're pushing towards RT0 at 6:12 p.m. Eastern Time in hopes of clearer skies, and the range is ready for support.
So it looks like we're ready to go here, guys. We're down to 2 minutes now. We're still green. Yeah, the Blue Origin rocket is New Glenn. I'm assuming that's the one you're talking about.
Stage 2 LOX loading should be completing here shortly.
If you're talking about New Shepard, the little one, that one had an accident, and
again,
you won't see that one flying until they figure that out.
In startup, where the first and second stages will begin pressurizing for launch, and Falcon's internal flight computers will take over the launch countdown.
Yeah, I don't know. I don't think you'll see the New Shepard flying for a little while longer, because they did have that failure, and they're gonna figure it out. And whenever Blue Origin tries to figure stuff out, it's always like, that's another year minimum.
Falcon 9 is in startup.
Falcon 9 is in startup. The internal flight computers have taken over the launch countdown.
All right, here we go. I think we're going to see this one fly today.
We have launch directors go for launch. All systems are go for launch of Falcon 9 with the O3b mPOWER payload.
T-minus 30 seconds.
So the fuel is RP1, and the oxidizer is liquid oxygen. That's what this rocket is running on. Falcon 9 and Falcon Heavy both run on that propellant. No boat jinxing now.
Minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition.
All right, here we go, guys.
And go.
Launch number 1 for the day.
SES O3b mPOWER.
Stage 1 propulsion is nominal.
Next thing to look out for is max Q, which will come up in about half a minute here. That's going to come when the vehicle hits about 1,500 kilometers per hour. You can see it in the left-hand corner there. And they'll be at about 10 kilometers of altitude. That's when the vehicle is has the most drag from
Falcon
the
9
atmosphere.
has successfully lifted off of Pad 40 at Cape Canaveral Space Force Station, carrying the O3b mPOWER payloads. During ascent, we tilt the engines, technically called gimbling, and this turns the rocket horizontally in what we call a gravity turn.
Supersonic.
You heard that call out that the vehicle is now supersonic, and we will be throttling the engines down in preparation for max Q, or maximum aerodynamic pressure, in just a couple seconds.
Max Q.
This is a great tracking shot here. I'm always a fan of the tracking shots, especially if they can get it all the way to stage separation. So that's going to come at T minus 3 minutes or so. Then the first stage will run out of fuel and it will separate.
Now we pass through max Q, and the rocket typically needs to go 17,500 miles per hour horizontally in order to avoid being pulled back down to Earth. You heard the call out that MVAC engine chill has begun. Now this is in preparation for 3 events coming up in quick succession, which is main engine cutoff, stage separation, and second engine startup 1. These 3 events will all be happening in about 30 seconds here, starting with main engine cutoff of those first stage engines that you can see on your screen right now.
This is such a great view. We get to see the curvature of the Earth, and you get to see those rocket plumes just getting wider and wider. And of course, that's because the atmosphere is getting thinner and thinner, so the gases are able to expand more when they leave the nozzle. But it's always really cool to see that physics in action.
And Biko.
Okay, now we're going to see that stage
Separation
separate.
confirmed.
There we go.
And back ignition.
And
This is
there you heard
looking
and
fantastic.
saw those 3 events happening back to back: main engine cutoff, stage separation, and that second engine startup 1 of our second stage. You can see those grid fins on the first stage deploying as the first stage begins to make its way back down to Earth. Now the next event in just a few seconds here will be fairing separation, where the 2 halves of the fairings will separate to reveal our O3b mPOWER satellites.
Now you can see the rocket engine is glowing. It doesn't actually use any active cooling in order to make it
Separation confirmed.
in order to make it stay intact.
There's that confirmation of fairing separation, and we will be attempting to retrieve these fairing halves again today once they fall back down to Earth using our recovery vessel, Bob.
Yeah, if you look at the
It's
camera,
T plus 3 minutes and 50 seconds here into today's mission, and we are in the first of 2 planned MVAC burns for satellite deployment.
Acquisition of signal, Bermuda.
so yeah, they don't cool the
In
nozzle with
about
fuel.
2.5 minutes here at T plus 6 minutes and 30 seconds, you should see on your screen the first stage's entry burn. Now for this entry burn, we relight 3 of the M1D engines, starting with
Instead of cooling the nozzle with fuel, they actually just radiatively cool this nozzle. So it's made out of Inconel, and it can basically get really, really hot. And there's a certain balance at which point it's radiating energy at the same rate that it's absorbing it from the exhaust gases. And that temperature that it balances at is actually less than the melting temperature of the nozzle, if they're using Inconel. Inconel is a material that can really go up to high temperatures. Astra would love to use that, but
And the
unfortunately,
first stage is making
the,
its way back down, preparing for its entry burn.
the budget
We
prevents us
perform
from
this entry
using
burn
that.
to help reduce re-entry forces on the first stage, which will help us recover and reuse the booster.
So that
Now again, during the re-entry,
that entry burn is actually going to create kind of like a shield that I was talking about before, that essentially will insulate the bottom of the rocket from the aerodynamic heating, because the temperature of the exhaust of the rocket is actually less than the temperature of the re-entry heating. So it's actually better for it to fly through its own plume than to fly with the atmosphere directly contacting the base where the engines sit.
again, that second stage is in the first of 3 planned burns, carrying our 2 O3b mPOWER satellites. And the first stage is coming down, awaiting the start of its entry burn at T plus 6 minutes and 30 seconds. This will be about a 20-second entry burn.
So the entry burn should be coming anytime here.
You can see the speed of both the first and second stages on the bottom left and right hand side of your screens respectively. First stage is about to start its entry burn.
Stage 1 FTS has saved.
Stage 1 entry burn startup.
Yeah, so
There's the start of the first stage entry burn.
basically they are using a PID controller to get to the drone ship. That's essentially how the software works. It's probably a bit more sophisticated than that, but as far as we know,
That was the
that's basically what they're
entry
doing.
burn from the first stage. Again, reusability is key to lowering the cost of spaceflight, which enables more investments in things like critical scientific research. Now, the Falcon 9 first stage that's supporting today's mission just performed its entry burn for the second time after previously having supported the Crew 6 launch just last month. Now, the Merlins on the first stage are optimized for sea level, whereas that MVAC engine you see on the second stage there is optimized for vacuum, which just means that it has a much bigger nozzle compared to the M1D engines on the first stage. Now, coming up in about 20 seconds, we'll have the shutdown of our MVAC engine on the second stage, followed quickly by the landing burn on our first stage.
So the landing was coming up here pretty quick. You can see that on the left we still have the first stage telemetry on there. We got the camera back. Fantastic. You can look at the shock waves around the grid fins. I love to see that. That is so cool. That was so cool to see. You can really see how those grid fins are working to keep the vehicle
There was
controllable.
confirmation of second engine cutoff
Nominal parking orbit insertion.
and a nominal orbital insertion.
Stage 1 landing burn.
This is
There is the
gorgeous.
start of our stage 1 landing burn.
It's
and you can see
amazing
that
how
drone ship
small
coming in
that drone
quick.
ship is. It's like a little dot. It's crazy they can navigate to it like that.
Stage 1 landing leg deploy.
Boom, right on the bullseye. Way to go, SpaceX.
What an awesome view of that first stage recovery. Everyone's very excited here in Hawthorne. And there you have it. That landing marks SpaceX's 188th recovery of an orbital class rocket, including first stage landings of Falcon 9 and Heavy. But the mission isn't over just yet. The second stage is now embarking on its first coast phase. Now, after this coast phase, we will light that MVAC engine for a second time around the T plus 27 minute mark. So we'll see you back here in about 17 minutes.
Okay. How about that? So we have a successful landing. Again. This is like the 150th time they've landed a booster or something. So I've lost count. Which is a good thing. This means that it's become basically a routine thing. Yeah. hopefully they can get this kind of reliability coming out of their Starship soon. That would be great. Yeah, for the amplifiers they're using to do the video and telemetry, yeah, I'm sure they must be pretty powerful. I bet you they're probably using Starlink, actually, to be honest. I would imagine they're like you could tell that about 2 years ago, once the Starlink started like coming into focus and being able to be used, like all of a sudden the telemetry from the SpaceX streams got like way better. So I feel like they're doing that. Yeah, thanks for joining, Xerxes. Yeah, definitely get some sleep. We'll be sticking around though. We're gonna try to catch the Falcon Heavy as well. So we'll see the finish of this mission here when they start up the engine again after the coast phase, and then hopefully we can switch over to the live stream of the Falcon Heavy, and we might be able to see that one launch as well. Yeah, it's pretty cool. They're launching them in rapid succession like this. That's definitely a bit unusual. Yeah, don't worry. You can catch what happened in the Heavy launch in the morning, I guess. So yeah, that's the Falcon 9, the workhorse of the SpaceX fleet. But next up, we're going to be having the Falcon Heavy. So I'm going to quickly go over a couple of things that are interesting about the Falcon Heavy. Hey, don't judge don't jinx the Falcon Heavy launch. We still want to see it. I think it's going to go because they had good weather for the Falcon 9. And whatever's good weather for the Falcon 9 is probably also good weather for the Falcon Heavy. Okay, great to see that you'll stick around to Tharva for the Heavy launch. So maybe I should put up the clock again. Let's see here. The official time for the Heavy launch is going to be in exactly an hour and 5 minutes. Okay. Just give me a second here. I'm going to redo the clock. Okay, so we should be set now for a launch coming up in an hour and 5 minutes. So this is for the Falcon Heavy. The clock down here is for the Falcon Heavy. The clock on the live stream is still for the second burn of the Falcon 9, which is going to hopefully be continuing the mission for SES O3b power. And that's going up to the medium Earth orbit so that it can do its communication mission. Yeah, see you later, Xerxes, and great having you. For those of you in America, you still have the opportunity, if you're living in the Florida region, to potentially see the Falcon Heavy launch. It's going to be a bit of a loud one, so if you're in the area, you will definitely notice it. But maybe we should talk a little bit about the Falcon Heavy, in case you are potentially a little less familiar with that vehicle. It doesn't launch that often, so it is a bit of a rarity when we do get to see it launch. Just to remind you that it is the second most powerful rocket that is currently operational right now. The only rocket that is bigger or more powerful than it is the SLS vehicle. I'm not sure. I don't think the Falcon Heavy will cross Pakistan. It's going to be going into a 28-degree orbit, if I'm not mistaken. So I don't know. Does that fly over Pakistan eventually? I don't imagine it will, because it's going to be going basically east from Cape Canaveral, and then it's going to basically cross over the equator, probably somewhere over Africa, and then it's going to be in the southern hemisphere. So I don't think it's going to be in the Pakistan region. So unfortunately, you probably won't be able to see it. In terms of the capabilities of the Falcon 9, it's quite a capable vehicle. It can get somewhere in the range of 64 tons to low Earth orbit if it's flying fully expendable. And it actually will be flying expendable for this mission. So it's going to get rid of all of its cores and also the center core. So everything will crash into the ocean and nothing will be recovered. And to be clear, the customer ViaSat is actually paying for this. So this is intentional. It's not like they've forgotten how to recover their rocket boosters. The boosters that they're flying here today are a bit old, and ViaSat has paid extra money so that they can expend the entire vehicle. The goal is to get that ViaSat satellite all the way up to geostationary orbit. And usually you go into like this elliptical orbit when you're going up to geostationary orbit. So that's like, it's called geostationary transfer orbit. And it's this elliptical orbit that goes from low Earth orbit all the way up to geostationary orbit. And it's ultimately the responsibility of the payload to get itself into the circularized geostationary orbit. But because Falcon Heavy is so powerful, you see here it can do 63 tons all the way to low Earth orbit, or 28 tons all the way to the transfer orbit. The size of this payload is only 6.7 tons. So it actually has enough fuel left that it can actually do the circularization and get it all the way to geostationary orbit all by itself. So ViaSat pays extra money so that they can do that. And the only consequence is that, well, unfortunately, they have to expend these boosters. So we won't get to see that picture-perfect landing of the two boosters coming back to the launch site. But we will still get to see the vehicle fly, and I don't know, maybe they'll have a camera on one of the boosters and we get to see it crash. That would be awesome. The death dive. All right. To get a bit of an idea of the profile the mission will have. So, of course, we'll have the liftoff, which will happen in exactly an hour. Then we're going to get booster separation. That's going to happen roughly 3 minutes into the mission. Those side boosters will be jettisoned from the vehicle, and the center core will be all that is left on at that point. I don't know if we'll have cameras on those boosters, but maybe we'll get lucky and they put a crash camera onto the booster. It would be such a cool thing to watch. I doubt they'll have that though, but maybe if we keep asking for it, they'll finally do it. The center core will burn for another minute or two, at which point it will disregard this the boost back burn. That's not going to happen because, of course, these are going to get expended. But after another couple minutes, the core stage will run out of fuel and it'll be detached, and the second stage will be able to carry the payload the rest of the way into orbit and then up into that geostationary orbit. The fairings will also be deployed. This is not a classified payload. I apologize. It will not be classified. We will actually be able to see what's going on up there. So we'll actually get to watch it perform the boost burns up into the transfer orbit. We will not be able to stay online for long enough to see the circularization, but ultimately we can be pretty confident that the mission will be successful after that point. And just to be clear, we will not be seeing the booster landing. This will not be happening. But we might get to see a crash view from the booster. I'm not sure if that will be the case, but it could be. One can always dream. So we're just roughly 7 or 8 minutes away from the next burn of the Falcon 9 mission with the SES O3b power mission. Yeah. In the meantime, if you guys have any questions about Rocketry or about ASTRA, what's going on at ASTRA right now, please feel free to ask. We're hoping that we'll get to see this rare SpaceX doubleheader where we get to see 2 rocket launches in the space of an hour. Definitely really excited to see it. Yeah, I don't think they really wait for these boosters like they did back in the NASA days. Then back then they were trying to get all the data they could, so they would be leaving boats all over the place to try to gather as much data about what's happening with the rockets and stuff. So I suspect that there's probably no one waiting for those boosters. They actually don't have the drone ship capacity to actually recover this, even if they wanted to, because they already sent one out to get the Falcon 9 mission that just launched. So that means they would need 2 more drone ships that were ready, also out there to catch the 2 side boosters. And that's just like, I think a bit beyond the capacity of SpaceX to operate at the moment. They could have also flown them back to shore, but that would take even more Delta V. So definitely beyond what they could do for this case. Yeah, how to provide funding for sponsorship to ASTRA. Well, we currently have a crowdfunding campaign that's going on right now. You can find that at Start Next. So if you go to the Start Next page and put in ASTRA, you could definitely find our crowdfunding page and hopefully be able to donate. You can also go to our website. There's a donate button there if you guys want. If that could also be an avenue through which you could support the team. But you can also, I think, support through just following up on us. Just your presence and your attention is definitely something that helps us along the way as well. So keep that in mind as well. What about engines? I'm not sure I understand the question. Like, you mean the engines of the boosters or what? Like in terms of the Navy ships waiting for them? Because I don't think I don't think anyone's going to be waiting for these boosters. Surprisingly, though, there are very few Falcon vehicles that are actually in the ocean because they recover them all, right? Compared to other launch vehicles. SpaceX is very environmentally friendly. They don't crash very many boosters in the ocean at all. Yeah, if people want to support ASTRA, please do. It's we are struggling right now, I would say, financially, because we're in that place where we're building a bunch of stuff and we're testing a bunch of stuff and we're building up to doing a launch campaign. So yeah, any little bit helps. And if you ever built a rocket, you know that they just eat money like crazy. So yeah, if you want to help support the team, definitely check out our Start Next crowdfunding campaign. It's almost finished now, so there's still a chance though to contribute if you're up for that. But yeah, we're looking forward to doing some testing with the propulsion system in about a week. So not a week, a month. It feels like a week. So yeah, we're looking forward to sharing that with you guys and demonstrating how we went about doing and building our engine and building our technology to be able to do it. We really want to showcase like all the parts of it, like in terms of the building process and how we designed each of the pieces, because we kind of want there to be more accessibility to how you go about building a system like this. And hopefully you'll be able to learn from our mistakes and also learn from our successes. That's actually a really good point. If you do crash engines into the ocean, you do run the risk that someone could come and try to copy your technology. That's true. But they would have to go to the ocean and fish the booster out of the ocean. And that is actually incredibly difficult. I believe that Jeff Bezos actually went and he fished out an Apollo rocket engine from the bottom of the ocean. The cost that it takes to do this is quite significant. Like, we're talking millions of dollars, tens of millions of dollars, because you have to charter a vessel that goes out and first looks for the booster. And then once you find it, you have to engage in this crazy recovery operation where you're pulling an object that's, tens of tons from the bottom of the seafloor, which is literally kilometers deep. So we're talking like big boats, like, offshore oil and gas type boats that cost hundreds of thousands of euros per day. And you could be out there for a couple weeks trying to do this. So if you have the resources to do that, the likelihood is that you probably already know how to make your own engine. So you don't need to copy off anyone else.
Back to the webcast of the Falcon 9 mission carrying the
And we're back here.
mPOWER satellites for our customer SES. Falcon 9 launched on time at 6:12 p.m. Eastern Time from Space Launch Complex 40. In addition to an on-time liftoff, we had successful main engine cutoff, stage separation, and the first of 3 burns of the second stage, bearing separation, and a successful first stage landing, which marked our 188th recovery of an orbital class booster and the second landing for this particular first stage.
188.
Now we're coming up on
Holy
our
crap.
second relight and shutdown of our MVAC engine at T plus 27 minutes and 10 seconds. So in just about 10 seconds, we will do a short 30-second relight in our second engine startup too.
So this is the startup that's going to get them into that transfer orbit. So they're going to be adding a couple thousand kilometers per hour of delta V. It's amazing how fast that engine lights up.
Too. And this burn is planned to last about 30 seconds.
And you can see like how much thrust to weight it has, because if you look at the bottom right hand corner, like that's the speed that it's going, and you can see it's like picking up, it's like speeding up by hundreds of kilometers per hour every second. It's crazy.
There is second engine cut off too. We'll wait to hear confirmation of a good orbit from the teams.
Nominal transfer orbit insertion.
There is that
Looks good.
confirmation of a good orbit. We have one more second stage to burn before the deployments of our O3b mPOWER payloads and satellites. The third and final burn of our second stage should occur in about 80 minutes from now. So until then, enjoy these views of space, and we'll see you again then.
All right. So that will be starting up again in about 80 minutes. But we have some more excitement before then, which is, of course, going to be the Falcon Heavy launch. So stay tuned. Do we use reaction control systems to control our rocket roll? The answer right now is no. This could be a big mistake. We are gambling that we can probably figure out how to keep the rocket out of the dangerous areas of roll just aerodynamically with our passive systems. So the key to roll stability is to make sure that you don't get roll pitch coupling. So if that happens, where the natural frequency of the vehicle in the pitch direction equals the roll rate, then you can get some weird effects where the rocket will start wobbling itself out of stability. And you could end up with the breakup of the vehicle because of the loadings aerodynamically on the vehicle. But as long as you stay away from the roll rate being in the same range as the natural frequency, you can actually avoid this problem. Now, you can be sure of this by adding thermal reaction control systems. So something like cold gas thrusters. But that is a bit of a complication. And as I said before, we, as a student group, strive to keep our solutions as simple as possible. So instead of doing that, we're just designing our fins to hopefully keep the roll rate in check. Whether that will work in practice or not, that's a bit unknown. But we're doing a lot of simulation and work on the fins themselves to try to make sure that we can achieve this. We will get a little bit of data from our small launch of Karma. Unfortunately, it doesn't go into the supersonic regime, so we won't really get testing of the fins in that area, which is potentially a little bit more important for solving this problem. Yeah, that's kind of the long-winded way of saying, no, we're not going to use cold gas thrusters. And as I said, that could be a mistake. But I think that it'll all work out in the end. Hey, maybe it'll work out. Who knows? In the meantime, we're not going to see another burn here for another hour and a half or so. So we're going to switch the stream over to the Falcon Heavy one. Just give me a second. Okay. So we're going to be waiting on the Falcon Heavy stream now. And that should be starting in roughly 30 minutes or so. So in the meantime, we can hang out, talk a little bit about rockets. Any more questions you have about Astra, be sure to ask. We got a lot of things going on right now, so there's lots to talk about. Did you miss something? I don't know. Did you miss the second burn of the of the Falcon 9? It just did its next maneuver. So again, the Falcon 9 was going into a medium Earth orbit. So the first burn just took it into a low Earth orbit, and then it had a coast phase, and then it put itself into a elliptical orbit. And that elliptical orbit is going to take it up to medium Earth orbit. And then it'll do a circularization when it gets up to medium Earth orbit all the way. Yeah. Can diamond coated thrusters replace Inconel? Oh man. I guess diamond can withstand high temperatures, so in theory, yes. But that would be one hell of an expensive nozzle. Like, diamonds are not cheap, dude. Holy crap. I guess if diamonds were cheap, then yeah, you could replace Inconel. But right now, I think Inconel's a lot cheaper than diamond. So usually how we build stuff for space has nothing to do with whether it's the most effective, and everything to do with is it possible to do on a budget. A lot of things are chosen just because they're the cheapest option available that will do the job. Like, fuel is a good example of this. Like, we have fuels that are super, super highly efficient. The main ones being hydrogen and oxygen, but a lot of rockets don't use that. And the reason is not because, oh, it's more efficient to do something else. It's just because it's cheaper to do something else, or, easier to design, and that makes the whole design process cheaper. So that's usually how these things shake out. If you got a jewelry store as a sponsor. Yeah, I mean, if they're willing to part with millions of euros worth of diamonds in order to make a nozzle work, I guess it could work. A better idea might be to try a ceramic coating for your nozzle. So some sort of ceramic material that can get really hot, and then hopefully that ceramic is cheaper than diamonds. that would be a technology that would be interesting to explore. Is how would you feel to get a ceramic sort of insulation to make a nozzle that can survive multiple burns? Yeah, right now we're using like the cheapest technology possible, ablative technology. So all of our surfaces on the nozzle will ablate. The graphite and the paper phenolic resin coating, they're designed to basically burn away as the hot gases flow through them, and that carries away the heat with it and keeps the structure around the nozzle cool. But of course, that's kind of single use, because once you do it once, then the insulation is gone, or the geometry of the throat has changed, and so you can't really use it again after that. Which books can I recommend for rocket science? Ha! I have a perfect answer for this. I happen to have the book right here. So, I think every rocket scientist should read this book first. It's called Rocket Propulsion Elements. It's written by Sutton and Biblarts. And this is like, I would say, the go-to book for introduction into rocket science. Also, as a little tidbit, it's actually the book that Elon Musk read before he started SpaceX. So it worked for him. There are a bunch of other books that you can also read, but this one kind of covers everything. So at least most things that are like at an introductory level. I think it does a really good job of like going over a lot of stuff and a lot of the concepts. There's lots of formulas in there for how to design things like your nozzle and your combustion chamber and tanks and all kinds of other stuff. Also, it has a lot of detail about the different materials you can use, the different types of engine cycles that you can pick and choose from. It also gives lots of good data from existing engines and other engines that are in development. So it tells you like what the performance is on them. So it really gives you the ability to start thinking critically. And if you're going into designing an engine, you can kind of think about what's possible and start thinking about how you would optimize for your specific situation that you're trying to design a rocket for. So yeah, that would be the one I would go for. Yeah, Tharva. I mean, if we can figure out how to make a ceramic coating work, then I would totally be down to think about how to do that for the Karma rocket, because the nozzle will be a lot bigger, and I don't think we have the resources right now to be able to build such a big nozzle ourselves. At least not with the tools that we have right now. So that will definitely be a problem that we'll have to conquer, and doing a big graphite block for that would just be kind of silly. We'll see. Yeah, the hydrazine is definitely on the cheap side, but of course, yeah, if you spill it, you're in trouble. That's one of those things that looks cheap at the start, but then gets more expensive as you get into it, because then you have to think about like containment. You have to have like zones where people aren't allowed to go. You have to do all kinds of crazy testing, because these, like, your tanks have to work, just period. Otherwise, people die. So yeah, it looks cheap at the start, like, oh, look at this cheap fuel. But then in the end, it's like, oof, I don't know. Might have been cheaper just to go with RP1 and liquid oxygen. I'm glad you appreciate the wonderful literature that is rocket propulsion elements. Yeah. Once you get into it, though, he also puts a lot of like after each chapter, he references all the things that he grabs the information from. So it gives you like the start of the web that you can start going down. Like, let's say you're interested in hybrid rockets, like we were, right? You could go to the hybrid rocket chapter and see like what he's referencing, and then you can go to those places and read those things, and then you kind of like start going down the web of information about what's available out for hybrid rockets. So definitely, it's definitely a great starting point, that book. Ceramic is also heavy, yes, but you can do a very thin coating, and that's enough. So like if you just had a way where you could build like a metal nozzle, like out of stainless steel or something, and then you just have to put a coating on it. So you just coat the inside of the nozzle with the ceramic, just so that the stainless steel doesn't melt, you know? In theory, it should work. Like if you do the thermal analysis, it should work. But you have to, you have to know how to do that. And we don't really know how to do that yet. Maybe we'll figure it out. Yeah, Richard Naka site. Yes, this is actually a great site. I highly recommend this site, by the way. It's very good for explaining like how to do things. Like if you want to know like the step-by-step process of how to make something or how to build something for amateur rocketry, I highly recommend the Naka site. It has proved invaluable. They have also like, if you want to get into like doing like solid propellant and stuff, like they talk about the formulas there, like of how to mix stuff properly. They also talk about the process that you have to go through in order to do it properly so you don't hurt yourself. It's really, really helpful. I highly recommend it. Some metal fusion methods. Yeah, I guess, I don't know. We could check those out. That's true. But you have to think about it in terms of like which metal is going to be able to survive the conditions that we're dealing with, right? The problem isn't necessarily that there are metals out there that can do it. It's that, are there metals that we can afford that we could do it with? Because if we end up at Inconel, that's going to be like thousands of euros. And that might be beyond our budget. It might be easier and cheaper if we just can make it work with stainless steel and a coating. Yeah, we'll see. Or maybe we can make it similar to the bronze nozzle that we're doing for Karma, and we can just have like a graphite insert and the hard paper as insulation. That might be enough. The trick will just be how do we manufacture those things, because the lathe that we're manufacturing the Karma nozzle on is much smaller, and it wouldn't be able to manufacture a Transcendence nozzle. That's for sure. So there's that. You know, just the small problems. This is another thing that you have to think about when you're building rockets, is it's not just, do you have the money and do you have the time? It's also, do you have the tools? So this is the problem with building a rocket that goes to space, is everything's bigger. And so you need bigger tools. And then usually for most people, you just don't have the tools to build such big things, In terms of what you need, it's like structures that are on the order of 5 to 10 meters long and are 200 to 250 millimeters wide, sometimes 300 millimeters wide, depending on what your solution is. So yeah, everything gets big fast. Our lathe can only handle up to 200 millimeters diameter, so unfortunately Transcendence is a bit too big for our tools. If you want to know more about the cost of what building a rocket that goes to space is like, we did do a video recently about that. It kind of goes over the costs that you would expect to pay for like each element of building a rocket. You will find that a lot of them are a lot bigger than you expect. So if this is something that you're interested in the future, or if you're just curious, what it takes, yeah, it'll definitely be a bit eye-opening. It was certainly eye-opening when I was initially going down the rabbit hole at the start of the project to try to figure out how much it would cost. Like in the end, we're probably going to spend about 10 times more than what I expected at the start. So yeah, classic aerospace engineer, grossly underestimating the cost of a project. For those just joining recently, we did just see the launch of the Falcon 9 with the SES O3b mPOWER satellite. Am I saying that all right? It's launched about just under 45 minutes ago, and everything went nominally. They were able to recover the booster, and the second stage is now happily cruising up to medium Earth orbit. There's another burn that's coming up in about an hour, but we are instead actually looking forward to the launch of the Falcon Heavy now. So this is a unique situation where we are getting to see 2 rockets for the price of 1. And both of them are flying from Kennedy Space Center in Florida. So it's a jam-packed launch weekend here, starting up on this Friday. And it's also a bit unique because I don't think we've ever seen 2 rockets fly from the same place on such a short period. Like usually they have to, there's a recycle time to a launch area where the people that are running the launch site have to kind of like, you know, it usually takes like 24 hours, but they're just going. So clearly they've solved this problem. And I'm looking forward to finally seeing the Falcon Heavy go because we don't get to see this one fly very often. And it's always great to see the second most powerful vehicle take to the skies. We will also get to see the Falcon Heavy today go to its absolutely max potential because it's going to be running in fully expendable mode. So that means they're going to get every single Delta V opportunity out of this vehicle today. They're going to ring it for everything it's got. And that's, of course, because ViaSat, which is the company that's paying for this launch, the satellite is trying to get all the way to geostationary orbit, and they're trying to directly insert it into that orbit. So this is something that only the Falcon 9 can really do. There aren't really any other launch vehicles that can do this type of a mission with a satellite that's as big as the ViaSat satellite is. Except for maybe the SLS, but yeah, they don't really use it for that. So I think it's a good thesis material topic for coating a metal nozzle to replace an canal. It could be. It could be a good topic. You have to do a little bit of research into it to see if it's actually economically viable in the commercial world, I think. Because what's economically viable in the amateur world might be very different than the commercial world. Because the commercial world, they have access to different material, different tools, I would say. Like, there's not many amateurs that are just going to have access to a metal 3D printer. But a professional company probably does. So maybe they can 3D print Inconel, and for them, it's easy and cheap to do that. Whereas for a student group, it's not. And so maybe for us, it might be cheaper to do, spend a bunch of time lathing a metal nozzle and then, coating it with something. For us, it's cheap because our time is, not worth anything. No one pays us to build the rockets. Which kind of it creates this deceptive thing where it makes something look cheap because students built it. And they spent a lot of time building it, but not necessarily a lot of resources. So it makes it look cheap, like, oh, they only did it for like 30 euros. But they spent tens of hours or maybe hundreds of hours doing that, building that one part. If somebody was being paid to do that, that part wouldn't be 30 euros anymore. It would probably be thousands of euros. So you kind of get the situation where even though something looks like it's cheap, it actually ends up not being so cheap. Are there any flat earthers? I hope not. My goodness. We're all watching rockets launch here to orbit. So if you're still a flat earther after seeing a rocket launch, I don't know. I mean, where are the rockets going if the Earth is flat? I'd be very curious. They got to be going somewhere. They don't come back down. Maybe they're just all flying to heaven. That's how they explain it in the flat Earth logic. I don't really understand the philosophy of flat earthers because there's just so much evidence that the Earth is not flat. It's very confusing. I feel like it's a failure of the education system. What was all recorded? What are you talking about? Yeah. I guess this is how a flat earther would respond to a rocket launch. I don't know. We got clear footage of the booster coming all the way back down to the ground. So that was, I don't know. That was pretty convincing that it at least went to space. And for the upper stage, we're going to get to see it relight in space after 80 minutes of coasting. So, how could you achieve that on a flat Earth? I don't know. It's basically going to have gone all the way around the Earth by then. But yeah, we'll see. So we're 25 minutes away from a potential launch of the Falcon Heavy. I think they're still scheduled to go. Let's just quickly check their Twitter, make sure nothing's changed. I think they're still gearing up to go here. The Falcon Heavy is on the pad, so I think we should be close to a launch here. And the live stream still is active. They're probably going to start in about 10 minutes or so. And just to be clear about the launch for the Falcon Heavy today, they are having a 57-minute launch window. So the window will open in 25 minutes, roughly. And then they do have roughly an hour to be able to launch the rocket. But I think they'll probably take advantage of the first part of that window because the weather was good for the Falcon 9 rocket. So they'll probably try to keep the weather on their side. They're flying in the same spot right now. They both are going out of Cape Canaveral. So they'll probably try to go to the earlier part of that window, I would assume. I don't think there are any flat earthers that are following this stream. I wouldn't expect any. I mean, why would you watch rocket launches if you're a flat earther? I feel like it's like watching evidence against your theory. Yeah. Another one of the interesting videos that we have coming up is one about the rocket injector. So, of course, when you're building a rocket, that's using a liquid propellant. In this case, we're using a liquid oxidizer in nitrous oxide. you have to somehow inject that into the combustion chamber. And so we have, we've designed basically our in-house injector, which we've built from scratch all by ourselves. And we were able to actually do some testing on it. So we will get to show you exactly how we went about doing that and actually how it's performing. So, and we actually tested different types of injectors as well. So we didn't just build one kind of injector. We built 2 different types. So we were able to compare them and see the different characteristics that they both have. And we're hoping to be able to also take both of those injectors to the propulsion testing that we're doing in a month and test them both and also get the difference in how they perform with propulsion involved. So do we get better efficiency and better flame with one injector over the other? That's the question. And both of these were designed in ways that you can easily manufacture on your own, even if you just have simple tools. So I think it's a really cool demonstration of how you can solve a problem just by kind of thinking outside of the box a little bit. Yeah, I don't think Werner von Braun would even tolerate a flat earther, to be honest. He'd probably just walk away. Be like, what are you talking about? Although it's kind of funny that sometimes there was this one post that the flat Earth community had where they said, we have thousands of members all around the globe. And it's like, wait, what? I thought you believe in a flat Earth. Yeah, the injector that we're using will be injecting the nitrous oxide in a liquid phase. So we're looking to have it atomize. That's the key. We tested the injectors with water. So water doesn't really atomize as well as nitrous oxide does. So we're giving ourselves a higher bar of operability in this sense. The nitrous oxide will not be gaseous in the injector holes according to our simulations. Hopefully that will be the case. If you get a lot of gas in the actual injector like holes that go into the combustion chamber, you can really run into some problems with like choking your flow. Yeah. So hopefully that's not going to happen. But again, we're complete noobs when it comes to designing injectors, so who knows? We'll find out at the propulsion test. But do keep an eye out for the video that we do about it, because I think it's quite enlightening, and it has some interesting ways that we've solved the problem of how to build an injector in the first place. Yeah. We're pretty excited for that propulsion test. It's definitely going to be the hardest test that we've done so far, and the one that's taken the most energy. There's just a lot of things that have to go exactly right in order to make it work. And the cost of failure is so high. Unfortunately. Just one mistake, and the whole thing goes kaboom. All right, so for those just joining, we are very close now to the start of the Falcon Heavy launch window. We already saw the Falcon 9 launch about an hour ago, and now we're looking forward to seeing the Falcon Heavy take to the skies. And both of them were launching from the same location, which is down in Florida at the Kennedy Space Center. This is a bit of a unique situation because it's not every day that you get to see 2 launches launch from roughly the same area, all within a 1 hour period. but we looks like we might get to see that today, which is pretty crazy. It's a crazy world we live in where rockets are just taking off this frequently, that there's like multiple per day from the same spot. Like we're getting there. We're getting closer. We're getting closer every year to just continuous operation of these launches. And just to give you a little bit of an idea of this, this is actually the launch frequency that SpaceX has so far throughout the years. And you can see that they've been basically growing in their launch frequency at nearly an exponential rate. To the point where last year they launched over 60 missions, which means that they flew more than once a week. I still remember just a couple years ago, where just seeing like one rocket launch every couple months was like a big deal. But now they're going so frequently. And this year they're going to launch probably closer to 100 rockets, because they're already at 26 rocket launches, I believe. As of this morning, it was 26. After today, it'll be 28. 28 launches, and it's still just April. So, yeah, we're definitely in a place where these rocket launches are becoming very frequent, which means that the space industry is expanding, and hopefully we're getting closer to kind of seeing space launches coming up to a similar frequency, hopefully in like 20, 30 years from now, as maybe air travel was back in the 1950s. If we can get to that point, that's going to be really a turning point in the space industry in general. And I would love to see it. So, the way that today's spanning out here, I think that this is kind of an indication of what's to come for the future, hopefully, where we get to see spaceports operating kind of more in like an airport fashion, where just lots of rockets go from them every single day. That's a world I want to live in. It also might make life a little easier for people trying to see these types of launches, because one of the things that sucks about going to see a rocket launch in person is that you go down there for the launch date, and then it gets delayed. And you'll go for a rocket launch like 3 times and never actually get to see the rocket launch. But if rocket launches are just going every day, maybe you missed the one you were trying to watch, but you get to see something else. One ticket from Pakistan to Mars. That would be fascinating. I don't know. How old are you? Maybe that's a book that can still be written. Yeah, I think we'll be on Mars sometime in the 2030s. So, whether it will be affordable for people to get to Mars, I think that's probably going to be something that won't happen for some decades after that. Unless you're someone who's going to work on Mars. Like, you're going there to build Mars. I think there's going to be a lot of people that go for that. Yeah. We'll see. I hope it becomes something that people do. I think it would be it's like today's cathedrals, This is the one thing that humanity can work together on and actually do something that just like defies expectation, You can fly in your mind. Yeah, I guess you could. Although I think that going in person would be quite experience in and of itself. Think about it. There's a whole planet there where no one has ever actually set eyes physically on anything. Like, the sheer opportunity for discovery there is just beyond me. I can only imagine. I'd be like a kid at Christmas. trying to check out everything, see what's over there. Also, for any sort of scientist, like, think about the difficulty that we have on Earth is that our sample size is always one. Like, oh, we want to know something about geography and geology and how rocks form and stuff. Well, all we have is Earth as an example in most cases. We have some probe data, like for the planets and the moons and stuff, which is certainly useful. But in terms of being able to dig down and actually, you know, do some geology, like, Earth is really the only example that we have. So being able to do that kind of stuff on other planets will definitely open a lot of doors in science, and trying to figure out basically how planets form and how how stuff works. I don't think you'll be alone on Mars. There'll be lots of people with you. I don't think we'll ever send someone by themselves to Mars. That would kind of be silly. It's definitely a situation where it would require lots of people. And I think the people that go will probably live there. So it'll kind of be more like people going to North America during like the 15 and 1600s. You know, like they move their lives there. It's going to be the new land of opportunity in the future. Like, I'm sick of Earth. Let's go start a new life on Mars. Yeah, I mean, there'll at the start there'll only be a few, but I think that, like, after the first decade, it's going to be more than a few. You know, economics will just drive activity. There will be economics related to having people on Mars, I'm sure. It'll probably start in the asteroid belt. It'll start becoming profitable to mine there, especially if the cost of getting to orbit goes down. It just needs to go down, I would say, by about a factor of 100 from Starship. And then mining the asteroid belt becomes economically viable. Once that happens, all bets are off. Then you're going to see space exploration absolutely explode, because all of a sudden there's huge economic reason to be operating in space, and that will change the game. Then you'll see things like millions of people living in space. I don't really think there is a place to live alone, unless you like really you'd have to really try. There's pretty much people everywhere on this planet. And if you go into space, you got to go with people. No one goes alone. For those just joining, we are still waiting for the Falcon Heavy to potentially take flight. It's scheduled to take off in just under 10 minutes. The launch window is an hour long. So the launch window will start in 10 minutes, but it can go for another hour. Anywhere in there, the Falcon Heavy could launch. Right now, the live stream hasn't started up yet, so I assume they're probably going to push back a little bit. Maybe they have released something on Twitter saying what's going on with this one, but I'm not sure. Let's see. Huh. It looks like everything is still a go here. Although it's hard to say. Okay, I think they're going to be pushing back to the end of the launch window. Ha! Shoot. Oh, man. Come on, SpaceX. Always messing with my sleep schedule. Okay, we might be waiting a bit longer. I think they have pushed back the launch to the end of the launch window, which is actually going to be in about an hour. Okay. Let's just quickly adjust the clock. So there we go. So in just over an hour, that will be the end of the launch window for the Falcon Heavy. If we don't have any more hiccups from now until then we will in fact get to see the Falcon Heavy launch. Otherwise, they do have the opportunity to recycle this one, I believe till tomorrow, but I'm not sure about that. I think they'll probably just recycle to tomorrow if they have an issue. Because they're just going to geostationary orbit, so it shouldn't be an issue with the instantaneous launch window stuff. So yeah, the ViaSat satellite is a communication satellite, which is going up to geostationary orbit. That is what the Falcon Heavy is going to be launching. It has, like I said before, it has that 57-minute launch window, which is going to start in about 5 minutes. They're not going to start the launch then. It looks like they're opting to go to the end of the launch window. It's probably for weather reasons, because the weather is a little bit tumultuous today in Florida. You saw in the Falcon 9 launch, it was a bit cloudy and rainy at the launch site. So I imagine that they're trying to thread the needle of when the weather is best. But in the meantime, while we wait for the Falcon Heavy, we can switch back to the Falcon 9 mission. They are going to have another burn coming up in about 30 minutes. So maybe we can look forward to that in the meantime. Let's just switch out the live feed here. So this is actually a live view that you're seeing of the Falcon 9, which is the one that just launched. It's currently on its elliptical orbit as it goes out to medium Earth orbit. So yeah, we might get to see some interesting views of the Earth along the way here. Huh. I love how SpaceX just like shows the view of the payload as it heads up to orbit. You can see it's kind of spinning there, so we might get to see some interesting views of the Earth and stuff. Always worth the wait. I like this view right here. You can't be a flat earther after you see that. Come on. You can like see half the Earth. Here, I'll get myself out of the way. I'll put myself over here. Yeah, I don't know. The flat earthers have some way to figure out how the round Earth in the camera from space is somehow not really the case. But I mean, come on. Like, look at that. And the reason why you can see Earth so well right now is because the payload right now is flying. It's not just in low Earth orbit. When you're in low Earth orbit, you can't really see the curvature of the Earth that well. Oh, did they just accidentally showed us a view of the tank? We just got one view for 1 split second there of the oxidizer tank. The stuff in there is top secret. Yeah, anyway, the reason why you can see the Earth so well is because of how far they are away from it. When you're in low Earth orbit, you can't really see the whole Earth because you're like really close to it still. So you just can kind of see the curvature of the Earth, but that's about it. But then when you get out to like over 5,000 kilometers away, which you can see in the altitude, on the bottom right hand of the screen, you can see the telemetry that's still getting read out. On the left hand side of there, you see the speed. And on the right, you see the altitude. And you can see they're still climbing. And at the altitude of 5,400 kilometers, you can really get some pretty good views of the whole Earth. So it would be nice if they would switch back to the cameras. I was enjoying it. I guess they're just going to hold us on the telemetry view. Anyways, what's happening right now is the vehicle, when it did its last burn, it was at the periapsis, right? And it put itself into that elliptical orbit. And now it's just coasting until it gets up to the top of that orbit, and then it's going to light its engine again to circularize. So yeah, that's just the general idea of kind of how they're doing this. It looks like they're still doing some outgassing stuff. I wonder if that's just like venting, or if they're actually doing like control of the spacecraft, because they're clearly spinning it. This is actually a good method that they they're definitely controlling it. This is one method that you can use. You can actually spin the spacecraft in order to generate microgravity, and that will actually control the behavior of the fluid inside of the tanks of the tank. Sort of the tanks of the tank. It'll control the fluid that's inside of the tank. The reason why that's important is because you need to make sure that the fluid is able to be sucked in by the pumps once you turn them on to light the engine again. So tanks will have all kinds of like crazy special structures in them in order to feed the fuel and the oxidizer towards the pumps, even if you're in low gravity. But sometimes they need like microgravity to help them out with that, and that's why they might choose to like spin the vehicle, and that kind of helps them out with, making that happen. But yeah, when they showed us that view of the tank, that was our little opportunity to see into what was going on. It would be nice if they went back to the camera view of the Earth. Show us the Earth. Just to give you an idea of when we expect the circularization to happen, they did say that it would be 80 minutes, 80 something minutes. I forget exactly which it was. A little bit over 80 minutes until they get to the top of the place where they're going to circularize. And we are almost there. It's just about 20 more minutes to go, I think. 20 to 25 minutes. But yeah, I find it very curious that they do so much active control even in this phase of the flight. I can really see a lot of stuff shooting out of the gas thrusters. Yeah, I'm ready. I'm ready with you there, Tharva. But we won't see the Falcon Heavy launch until the end of launch window. That's quite clear at this point. So that's going to be in about 50 minutes. So we will definitely see the circularization of the Falcon 9 launch first. And then we can hopefully head over to the Falcon Heavy stream. I'm hoping they're still going to decide to launch that today. For some reason, SpaceX isn't tweeting about this one as much. But they have officially stated the new T0, which is going to be in 50 minutes. And they say it's 70% favorable for weather. So hopefully that's enough. Whenever it's over 50, it's always a good sign with rocketry. I feel like the probabilities aren't exactly correct. Like whenever they say, okay, the weather is 30%, that means they're not launching. They should just call it 0. I've almost never seen them launch a rocket with a 30% weather probability. But whenever they're at like 70 to 80%, that means that like, okay, it's probably going to launch. Oh, here we go. The Earth view again. Look at that beautiful Earth. How could one deny the circular nature of the Earth after seeing that? Yeah. What we got to do is get one of the flat earthers to actually take their own camera. Like they get to choose the camera they use, and then they can install it onto a launch vehicle. And then when we see the views from it, it's their camera. So they can't deny the reality of their own camera, can they? Yeah, it's okay. I should rephrase. Spherical, not circular. Do flat earthers believe it's circular? So it's like a disc? That's how it works? Why not a square? You could have a square Earth. Then Earth could have a corner. Maybe Earth is a hexagon. I think that would be sexier. The hexagon Earth. All right. So we are, in fact, halfway through our double header here, which is the opportunity to see both the Falcon 9 and the Falcon Heavy launch in one sitting. It was supposed to be just an hour apart, but it's kind of been extended here to about 2 hours. The Falcon Heavy is delaying to the end of its launch window. So if you're just joining, the launch window has already started. It started about 10 minutes ago. The Falcon Heavy launch window will extend until 50 minutes from now. So we have 50 more minutes. The new T0 that they said was basically at the end of the launch window. The reason for this is that the weather in Florida is not really the greatest. So they're basically waiting until the very end of the window to have the best probability of having good weather to launch. Right now, according to them, the probability is 70% go, 30% no go. So I'm still hopeful that we will be able to see both of these rockets launch today. We already saw one. And it'd be great to finish it off with a Falcon Heavy launch as well. And look at that beautiful Earth showing up in the camera view. Right now we're just watching the camera views from the Falcon 9, which just launched. It's currently floating up to a medium Earth orbit. This is its mission parameters. It's sending a satellite called SES O3b mPOWER, and this is a communication satellite which is going into medium Earth orbit. And the nice thing about a medium Earth orbit is that you really get the opportunity to see the Earth in all its grandeur. So there you can see the whole disk of the Earth showing up. It's not like low Earth orbit where you just see like you're really zoomed in on the Earth and just kind of see the curvature a little bit, but you don't really get to see the whole thing. Here we actually get to see like big swaths of the Earth all at once, because we're further away when you're flying up to apogee in this medium Earth orbit. This rocket is going to do a circularization maneuver in about 20 minutes. So we will also get the opportunity to see that. Once that's completed, we'll be switching over to see, hopefully, the Falcon Heavy initiate its launch. Again, that's targeting the end of the launch window, which is coming up in about 50 minutes or so. Another interesting fact about the medium Earth orbit is that it is actually where most of the navigation satellites are. So satellites like your GPS and GLONASS, or I'm not really sure which one the Europeans use. I guess that's the Galileo satellites. All of them operate in these medium Earth orbits. The reason for that is quite interesting. You want to have satellites that have a large field of view when you're doing navigation. So low Earth orbit doesn't really make sense because you're so close to the Earth. You can only see little patches of the Earth at once. But when you're out in that medium Earth orbit, you're really able to see a lot of the Earth at once. And that allows people that are on the ground, which have, the signal receivers, they can ping multiple satellites at the same time. And the way navigation satellites work is you have to actually have connection with at least 4 satellites in order to fix a location. And you need more than that, more satellites than that, if those satellites are not directly like orthogonal to each other. So they work best the more satellites you have connection with. So if you want to have connection to a lot of satellites at any given time, you need to have lots of satellites that are in view, and that just works better at this medium Earth orbit than it does in low Earth orbit, because then you can build an array of satellites where in low Earth orbit you might have to build like hundreds of satellites. In the medium Earth orbit you just have to build like a couple dozen. So this location is primarily used for functions like that. And that's exactly what this satellite is. It's a communication and navigation satellite. In the meantime, if you guys have any questions about rocketry in general, or any questions about ASTRA, of course, my name is Josiah, and I'm a chief engineer at ASTRA, which is a student rocketry group that operates out of Bremen. We are currently working hard to build a rocket which will eventually reach space. This is a common goal that student rocketry groups have. There's actually only one group in the world that's ever been able to achieve it at the student level, and that's a group from America, from the University of Southern California. And of course, we would like to be in the ranks of a group that can get to this milestone, and hopefully bring this achievement also to Europe. So we want to actually be the first European group to reach this target. And interestingly enough, there was actually a new European rocketry record, which was set just a week ago by another rocket group that's in Germany called High End. They were able to launch a hybrid rocket, much in the similar design as our own, although we probably copied them more than they copied us, seeing as they have already launched their rocket. They launched a hybrid rocket, which runs on nitrous oxide, and they reached an altitude of 64 kilometers. So that's a new European record for amateur rocketry, and it's also the world record for hybrid rocketry at the student level. So we'd like to congratulate High End on this amazing achievement. And of course, we also want to let them know that we're coming for their record. So we're still here, slowly waiting for the Falcon 9 to slowly drift up to the apogee of this medium Earth orbit. We only have about 15 or so minutes left before it's going to execute its circularization burn. And that's going to put it exactly where it needs to be for this mission. Once that's complete, we will then head over and try to catch the Falcon Heavy launch, which should be happening in, let's see, where's my clock? It should be happening in about 40 minutes. I'm really looking forward to it because it's not every day you get to see a Falcon Heavy launch. And if it gets to launch on the same day as the Falcon 9, well, then it's just two for the price of one. So be sure to get ready. I'm fairly confident that the Falcon Heavy will also launch. They were about 70% go last I checked in terms of weather. And that's pretty much the only thing that stops SpaceX launches at this point, at least for the Falcon 9 and the Falcon Heavy. They don't really have any technical glitches anymore. Their programs are so deep at this point, and they launch so frequently that they've pretty much encountered every single error point at this point. How would you get to Mars on your own in those 40 minutes? If you got to Mars in 40 minutes, that's almost as fast as the speed of light, so that's pretty quick. I hope they should show more views of the Earth. That would be really nice. I guess if you're drunk enough, you can go anywhere, right? Are you going to be around to work on the tank tomorrow with Arva? Or are you going to be too hungover? We got to get this tank working, man. It's really incredible how peaceful it is. Just watching this thing slowly coast up to apogee. It would be quite the experience to catch a ride one day. Glad to hear that you'll be here with Arva. We have lots of work to do. For the context of those who are not in the ASTRA group, we're currently hard at work trying to fix our carbon fiber tank. We actually ended up blowing up the last one in our latest pressure test. So we had to quickly remake one in order to get ourselves ready for the propulsion testing that's happening very soon. So now we've created 2 more tanks that we're going to be preparing and testing in the coming weeks. And hopefully we've solved the problem that we encountered in that first pressure test, or shall I say second pressure test. Yeah, building a carbon fiber tank has proven to be a bit more challenging than we were expecting. In the end, maybe stick to metal materials. It might be easier. We've wound like 6 tubes at this point. It's really getting ridiculous. If you look at my my room, it's just like covered with rocket tanks and parts. Here, I'll show you. You can see over there in the corner, like I literally have like so many carbon fiber wrapped tanks just standing around. Oh, the joys of being an amateur rocketeer. All right. Yeah. I have so much carbon fiber floating around my house, it's like becoming a part of me. Another one of the issues of working with carbon fiber is that I really advise you wear gloves, because it does have a tendency to give you splinters, and they're a lot worse than the wood splinters. And so yeah, my hands are often covered with the damage of working with carbon fiber. I'm sure it's going to affect my lifespan or something. But whatever, that's the cost of space. Here we go, we're getting a bit of the sun in this picture. So you can still tell that the rocket is spinning. That's definitely intentional. It makes sure that the liquid propellant is properly settled in the tanks, and it helps with them feeding the engines for when the next burn comes. Without that, SpaceX would have a really hard time getting their relight. There, look at that view of the Earth. Look at that. Absolutely gorgeous. They should just stay on that camera. Stop switching. That's the best camera. You can tell they're getting pretty close to apogee because the altitude ticker on the bottom right hand is starting to go up a lot slower than it was before. That means they're getting close to apogee. Absolutely gorgeous. Look at that. Look at that camera view. Like, it's just incredible. The Earth is really amazing, I have to say. It looks really great in the picture. Yeah, that's another good point. What would make Earth so special that it needs to be flat, but everything else can be a sphere? Kind of strange. I wonder if we sent a flat earther to another planet, would they then think that planet is flat? They should just stay on this view. It's absolutely incredible. Can we tell where we are right now? I think it's somewhere over Australia or something. Or over the Pacific Ocean even. It's probably over the Pacific Ocean right now. Because I didn't see much land in the picture. Huh. Can we tell? I see some landmass there up in the top of the screen, but I can't really tell what it looks like. It's also hard to tell the orientation. Yeah, that's a good quote. We went to explore the moon and discovered the Earth. Yeah, because no one had ever really seen the Earth from that vantage point. Yeah. Definitely a different perspective. That's for sure. Well, we're coming up on this next burn. You can see it on the ticker there, slowly creeping up. It's the next milestone on the countdown. I think we have about 10 more minutes, if I'm not mistaken. And the vehicle is going to be cruising up to an altitude of roughly 7,000 kilometers before it executes this burn. Probably just over 7,000 kilometers. And hopefully we get to see some nice views of the Earth over the next couple of minutes here. Yeah, we're just doing this as a little bit of an entertainment as we wait for the launch of the Falcon Heavy, which is coming. Currently it's scheduled to launch in around 35 minutes. So be sure to stay tuned. Hopefully we'll get to see both launches. We just saw the Falcon 9 launch about an hour and a half ago. And hopefully we'll be able to also see the Falcon Heavy launch as well, thereby giving us the double header. It's also launching from a similar location as the Falcon 9 just launched from. It's down in Florida at the Kennedy Space Center. Both vehicles were on the pad at the same time. And if all goes well, we should see them both launch on the same day, which is definitely very cool. Something you don't see every day. That's actually a really good question. How do we decide whether to do, or now who's deciding this? Usually it's the customer that decides this. So I'll answer the question in this way. How does the customer decide whether to do an elliptical orbit to MEO versus doing a direct insertion? So basically it comes down to cost and how the customer wants to operate. So if you're deciding to go with a lower power launch vehicle, right, you would then choose to potentially just go to LEO and then just go to the transfer orbit, and then the payload would just circularize itself when it gets up to geostationary orbit. Different launchers have different capabilities. So some launchers don't have relight. They can't relight the engine. So once they start the engine, they can't stop it and start it again. A good example of this is the Ariane 5. So it can't relight its upper stage engine. So once it starts, it can't restart again. So it actually can't circularize ever. The Ariane 5 actually has enough power to circularize some payloads in some situations where the payloads are light, but they didn't design the Ariane 5 with that in mind. They just the parameter that it does is it takes things to the transfer orbit, and then it goes off and lets the payload do the rest of the work. The Falcon 9 and the Falcon Heavy were not designed with this limitation because, of course, SpaceX is trying to reuse all their rockets, and in order to do that, they have to be able to relight them. So they just designed all their rockets to be able to be relit. So for them, it makes way more sense to offer to their customers that they can do these direct insertions. And the customer likes that because it makes it a lot easier for them, because now they don't have to design a propulsion system which can do that circularization. So from the customer perspective, they usually would prefer not to have to circularize themselves, because then they don't have to worry about building a propulsion system that can do that. And if the launch vehicle is capable of it and can do it for the same price as the other launch vehicles can, which in the case of SpaceX, they can, it just makes sense. So yeah, this is another way that SpaceX is really able to totally outcompete everyone in the globe, because I think they're the only launch vehicle right now that's offering this capability in this way. So they can get like really heavy payloads and they can just circularize them at GEO and at MEO, which is, pretty crazy. Yeah. But despite this, there are some payloads, some companies that they have lots of experience building systems that circularize the satellites, and then they just don't care. Now, what you just saw there was actually a propellant settling maneuver. If they switch back to the camera, oh, geez, you saw that there was some gases being shot out, basically the back of the rocket, right there. What the vehicle is trying to do right now is it's trying to, first of all, stop the spin. And second of all, it's trying to push the fluid to the bottom of the tanks. And it's going to do this to help basically get the fluid ready to be sucked in by the engine, which is going to come up in a couple of minutes here. Or we might be under a minute now at this point. The rocket has to do this before it starts, before it gets ready for a burn, because the fluid has just been floating around in there for the last hour and a half. So you don't want to light the engines and have like no fluid to grab. Otherwise, you could cavitate the pumps, which is really bad. Then the rocket wouldn't work anymore. Just another clever solution they have to operating in zero gravity and allowing this engine to relight. So we should see this engine fire up real soon. You can see it continuing to do that propellant settling maneuver. I'm not sure if we're going to get our announcers back or if they will just go straight into the burn, but let's see what happens. Oh, they are back.
To the webcast for O3b mPOWER. So far in the mission, we had an on-time liftoff at 6:12 p.m. Eastern Time, followed by successful ascent, stage separation, first stage landing, and 2 second stage engine burns. We're now coming up on the third and final second stage engine burn before the 2 payload deployments. Should be happening in just a few seconds.
Okay, the engine's starting up. Here we go.
There is the start of that burn.
It's doing the circularization
And
maneuver.
this is a quick burn and should last around 30 seconds.
So right now the rocket is circularizing the orbit of the payload. And it's finished. That was it.
There was second engine shut off there for the third time. Now we were waiting on confirmation of a good orbit from the teams.
Nominal mission orbit insertion.
Looks like we're good, guys.
There is that confirmation of nominal orbital insertion. And as a reminder, the O3b satellites are still attached to Falcon 9's second stage. The first payload deployment will occur in about 3 minutes from now. Now, as mentioned previously, our customer today is SES. SES's O3b mPOWER communication system comprises an initial constellation of 11 high throughput and low latency satellites, as well as an extensive ground infrastructure. The O3b mPOWER satellites were collaboratively designed by SES and Boeing, and these satellites are SES's second generation MEO system that has been delivering high performance communication services since 2014 to customers operating in nearly 50 countries today. Now, the spacecraft deploying today will operate from medium Earth orbit, which is MEO, at 8,000 kilometers from the Earth's surface. Now, as mentioned previously, today's launch is the second of the 5 O3b mPOWER launches, with service introduction scheduled for later this year. Now we're coming up on the first of 2 payload deployments at T plus 1 hour, 53 minutes and 19 seconds, so a little over a minute from now.
So we're going to get to see those payloads be ejected with the payload separation systems.
The second stage MVAC engine there on your screen. It is still carrying the 2 O3b mPOWER satellites.
And these separation systems are...
You see a view of the payload adapter there.
These separation systems are usually hydraulic. SpaceX likes to use hydraulics in order to do these types of things. But spring deployment systems are also
less than
commonly
a minute
in use.
from the first of the 2 satellite deployments. It's worth noting that we previously launched 2 O3b mPOWER satellites in December of last year. So this launch will mark the 3rd and 4th satellites of the O3b mPOWER satellite constellation.
So we should see something here pretty soon. Just a couple of seconds.
Everything is continuing to look good on the second stage, and the payloads were a little less than 20 seconds from that first deployment.
So basically we'll just see the payload start floating away, if all goes well.
First payload separation confirmed.
You heard that call out with the
Are they not showing
confirmation
it?
of a successful deployment of that first satellite. Now with that confirmation, we do have one more major milestone left in our mission, and that's the deployment of the second and final spacecraft for SES O3b mPOWER. The second deployment is scheduled to happen in about 6 minutes from now. So in the meanwhile, enjoy the space views once again, and we'll see you here very shortly.
Huh. Well, I'm not... I guess we didn't really get to see the deployment part of that, but okay. Let's see where we are on the Falcon Heavy launch. It looks like it's starting up, so maybe we will switch over to the Falcon Heavy stream. Yeah, let's do that. Let's switch over to the Falcon Heavy stream. So... So, everybody, welcome finally to the stream of the Falcon Heavy, which will be launching in about 15 minutes. The Falcon Heavy, of course, is the biggest successfully operating vehicle that SpaceX has to offer. And we have just seen the launch of the Falcon 9 about 2 hours ago, and we're hoping to also see the launch of the Falcon Heavy here. It'll be flying a satellite called ViaSat, and it's going to be going all the way to geostationary orbit. It's not just going to do the elliptical transfer orbit. It's actually going to go straight to that geostationary orbit. That's what ViaSat has asked for, and that's what they've paid for. Uniquely, this means that the Falcon Heavy is going to be fully expended. They're going to squeeze every last bit of juice out of this thing to try to get it as far as they possibly can in order to satisfy the ViaSat customer. So unfortunately, we won't get to see those boosters landing back at the launch site, as we usually do with Falcon Heavy launches. But we're still going to get to see some pretty awesome views, and we're going to get to see the Falcon Heavy pushed to its absolute extreme in a way that it hasn't been pushed to date. So let's get ready to see some crazy rocket action. There is a launch window that we have for today. It's going from about 40 minutes ago to our expected launch time, which is coming up in about 18 minutes, 17 minutes. It's 17 minutes. So we're just waiting on SpaceX for when they're going to initiate their live stream. It's probably going to start in about 5 or 6 more minutes. In the meantime, we can chat a little bit about the Falcon Heavy vehicle itself and what it's capable of. But also we can talk about anything about Rocketry if you have questions, questions about what this mission is, or questions about Rocketry in general. Please feel free to ask. I am, of course, Josiah, your host. I am a chief engineer at ASTRA, which is a student rocketry group that operates out of Bremen. We are currently trying to build a rocket, which we're trying to get to space. And of course, we like to take inspiration from the commercial world. And this gives us an opportunity to sit and chat with some of you guys, talk about rockets, sometimes talk a bit about Astra's progress, what's going on there, and also get to see some cool launches. And today has certainly not disappointed. We got to see the launch of the Falcon 9, and we're looking forward to be able to see the Falcon Heavy in just a couple of minutes. It looks like we are probably going to get to see this thing launch. They're about 70% go for weather, which I think is a good sign. Because that's pretty much the only thing that stops SpaceX vehicles from launching at this point. Yeah, the boosters won't take the rocket all the way to Leo, but they will take them as far as they possibly can, which will be a lot further than they usually take the vehicle, because of course they need to do the boost back burn and stuff. Basically, the boosters are going to take the vehicle like a third of the way to orbit. The core will take it about 2/3 of the way to orbit ish, and the upper stage will do the rest of the work from there.
Welcome to our live webcast of the ViaSat-3 America's mission from SpaceX headquarters here in Hawthorne, California. My name is Atticus Federa, and I'm a propulsion engineer here at SpaceX.
This rocket looks so weird because you can see one of them is like way more used than the other one, the booster. So one of them's like black and the other one's gray. The one that's black has actually flown 8 times, so it's a bit toasty.
High quality, secure, affordable, and fast connections to enhance the lives of people all over the world. Our main payload today, ViaSat-3, is one of 3 satellites that will make up a constellation. It's expected to be the world's highest capacity satellite and will be the largest all-electric satellite ever to be launched. In addition to ViaSat-3, we also have 2 secondary payloads on board the second stage. Those 2 payloads are Astronis' first micro-geosatellite and Gravity's CubeSat Gravity Space 1. Both are scheduled to deploy after ViaSat-3, which will be a few hours after liftoff. and we'll have more about those secondary payloads.
Of course, they could paint the boosters so they're the same color, but the paint just adds extra weight. So like, why mess with it? The color doesn't really matter, right? So
we will not be recovering the side boosters or the center core, and instead we will be burning the fuel that we typically use for landing the boosters. You'll notice there at the bottom of the rocket on your screen, we have actually removed the landing legs as well as the grid fins. This helps us get just a little bit of extra performance by saving mass.
man, those rockets
We will
look
be
like
lighting
they're
our Merlin vacuum engine 3 times today, and
They look
that
like they're
last turn
naked.
will take place at around the T plus 4 hour and 20-minute mark into flight. And deployment of our payloads will begin shortly after that and wrap up about 25 minutes after the start of payload deploy. That makes our mission for today just under 5 hours long. Now at T-minus 13 minutes and 30 seconds, all systems are currently a go for an on-time liftoff. The vehicle is nearly fully loaded with propellant. The range is green and ready to support. Now, if for some reason we do not launch today, we do have a backup opportunity tomorrow at the same time. Now at just about 13 minutes and 10 seconds until launch, let's take a closer look at the Falcon Heavy vehicle on your screen.
Hello, everyone. I'm Jessie Anderson, a production and engineering manager here at SpaceX. Falcon Heavy is essentially 3 Falcon 9 rockets strapped together, which means it can carry much larger payloads. Like the Falcon 9, Falcon Heavy is a 2-stage launch vehicle. The big difference is that the Falcon Heavy first stage is comprised of 3 cores, while Falcon 9 only has 1. Falcon Heavy has 28 engines total. Each one of these boosters has 9 Merlin 1D engines, making for a total of 27 engines across all 3 boosters, and you can see that there on your screen. The 28th engine is a Merlin vacuum engine on the second stage and will power the payload to its final targeted orbit. Altogether, the Merlin 1D engines at the base of Falcon Heavy produce 5 million pounds of thrust. That's equal to 18 747s at takeoff. The engines produce so much power that we don't run them at full thrust all at once until after liftoff. About 3 minutes into flight, the 2 side boosters will separate from the center core. Each side booster has flown before, one booster having flown twice and the other 7 times before. Upon side booster separation, the center core will keep firing for about another minute before shutting down its engines and then perform a standard stage separation from the second stage. Our center core today is flying for the first and only time, and as Atticus mentioned, we will not be attempting to recover our side boosters or center core on today's mission.
no recovery today.
Now moving towards
Unfortunately.
the top of the vehicle, what you're seeing on your screen, on top of the first stage is the second stage, and after they separate from each other, the second stage will propel our payload to its intended orbit. Now you'll notice some gray paint on the second stage today, and that is to help absorb some of the heat from the sun to keep our fuel warm during the long coast flight.
They're worried
And
about keeping the
above
fuel
the
warm?
second stage is where our payloads
I guess for the RP1.
are safely enclosed inside of the fairing. The fairing protects the payload from aerothermal loads, heating, and contamination during ascent. But once we reach the vacuum of space, we no longer need this protection, so we will jettison the fairing as the second stage continues on its journey to orbit. And we will be attempting to recover the fairing halves today with our recovery vessel named Doug.
Oh, so we get some recovery. At least something will be
earlier,
recovered.
Today's launch is for our customer ViaSat. ViaSat-3 is the first of 3 satellites that will make up a brand new global constellation. And with that, here's a video further explaining our mission and our payload for today.
So there isn't going to be anything controlling the flow rate of the nitrous oxide for our rockets, for the rocket that ASTRA's building. It's just on off. So we'll just turn it on and turn it off. And we don't have relight capability, so it's just basically once you light it, it's going. We may choose to have a valve that is controllable, but that remains to be seen yet, and would require some more avionics work, essentially. But we'll see. In order for the rocket that we're building for the European Rocketry competition, we may choose to put a valve that we can control in, just so that we can hit the target altitude exactly. But we'll see. Just to reiterate, this Falcon Heavy mission, it's going to be not recovering anything today except for those payload fairings. The reason why it's not recovering those boosters is because it's trying to squeeze all the performance that it can out of the booster. As they mentioned in the stream a couple minutes ago, this is one of the largest geostationary satellites that's ever been built. And the reason why they can build it so big is because they don't need to pack any fuel with them in order to get them all the way circularized from the transfer orbit. And that's because SpaceX is delivering them straight to geostationary orbit. This allows them to basically build a bigger satellite that can, do more communication stuff, which is what they're essentially doing. You can see how they're positioning those satellites in kind of a triangle, and that allows them to have global coverage from geostationary orbit. So yeah, that'll definitely be an interesting mission for SpaceX, and one that definitely demonstrates the true capabilities of the Falcon Heavy vehicle. Unfortunately, we don't get to see the recovery, but I think that SpaceX is kind of using some of their much older boosters for this mission. So I don't think those boosters that they will lose are very missed, so to say.
Making these big leaps in technology, then that's cool.
If you look at the progression from ViaSat-1 to ViaSat-2 to ViaSat.
For those coming to build a tank at my house tomorrow, we'll be starting at 11 a.m.
Multiples of capacity.
We took things that were twice the size of a human and brought it down to barely the size of a shoebox.
The satellite design process is no longer buy parts and boxes and hook them up.
What we wanted was to invest in technology that can really scale. It's not just a new satellite design, it's a new way to build satellites.
We've had to reinvent all parts of the system.
I want to thank everybody at ViaSat for their role
like
in what we're about to do
this satellite
today.
is
And of
gigantic.
course, I want to thank our partners at Boeing. We wouldn't be where we are today without their support.
Many of us have spent several years working on this ViaSat-3 Flight 1, America's satellite. Today is the day.
With the ViaSat-3 constellation, billions of people can access more of the world, unlocking opportunity for everyone, everywhere. Starting now.
Crazy looking satellite.
At T-minus 6.5 minutes, the SpaceX team continues to count down for launch of our fifth operational
booster RP1 load complete.
Glad you enjoyed it,
fifth
Arva.
operational Falcon Heavy flight, and all systems are go. Following a successful static fire on Thursday, April 13th, Falcon Heavy rolled out to the pad with the payload Tuesday night and went vertical several hours later. Before we began the webcast, the SpaceX launch director polled the members of the launch team and got a go for propellant loading and launch. We're currently loading propellant on both side boosters, center core, as well as the second stage. You may be able to hear the live rocket sounds from our launch pad. Those pops and hissing sounds that you hear are from propellant loading, as well as the launch mount and strong back that propellant is flowing through. Falcon Heavy uses two propellants, a refined form of kerosene called RP1 or rocket propellant 1 as a fuel, and liquid oxygen or LOX as an oxidizer. An oxidizer is a type of chemical that a fuel requires in order to burn. The liquid oxygen is chilled below its boiling point so that it has a much greater mass per volume, and so basically we can load more of it into the rocket. Our fuel is RP1, essentially a purified kerosene. It is safe, easily available, and has a lot of history. As a fun fact, the Saturn V first stage flown from this very pad on the moon missions also used liquid oxygen and kerosene. And in addition to these two propellants, we also use the chemical TTEB or triethyl aluminum.
Falcon Heavy tanks are pressurizing for strong back retract.
TTEB is triethyl aluminum and triethyl borane, and that is an ignition source. The combustion of RP1 and liquid oxygen is what lifts the vehicle off the ground, and it's the TTEB that sets the match to the propellant mix.
That TTEB is
Next
hypergolic.
up, that truss structure that you see next to the vehicle, known as the strong back, will start to retract. And in preparation for retraction, those clamp arms
retract in progress.
Those clamp arms that you see just below the fairing on the second stage, they will open up, and this is to allow the strongback to recline away from the Falcon Heavy and clear its way for ascent. We should be seeing those arms open any second now. As you can see on your screen, those clamp arms are beginning to open.
Beautiful.
This is in
I
preparation
think we're going to
for
see a
strongback
launch,
extraction.
guys. I hope it's not too cloudy and we can still get some nice tracking shots.
NY booster locks load complete.
As we mentioned earlier, today's launch marks our second Falcon Heavy flight in just 15 weeks.
PY booster locks load complete.
And for those of you following along, a lot will happen in the first 4 minutes of flight. First, we will light the two side boosters, followed by the center core. Then about 40 seconds after liftoff, we decrease power on the two side boosters to prepare for max Q, after which Falcon Heavy will throttle back up to full power on the side boosters. 2 minutes into flight, we again reduce thrust on the two side boosters, but this time it's to decrease...
Center core locks load complete.
Just hearing some good call-outs for prop loading. This time it will be to decrease forces on the rocket structure, as the vehicle will now be much lighter, but thrust will be constant. Around 3 minutes into flight, we fully turn off the side boosters with booster engine cutoff, or what we call BECO. The pneumatic separation system on the center core then unlocks the two side boosters and pushes them away. Once clear of the side boosters, the center core throttles up to full power until the center core shuts down with main engine cutoff, or what we call MECO, and separates from the second stage around the 4 minute mark. And as a reminder, we will not be attempting to land our side boosters or center core today, as the mission requires more performance. From this point on, very similar to a Falcon 9 mission, the side boosters will be making their way back to Earth for a less elegant water landing. The fairing halves will separate, and the second stage will take the ViaSat-3, Gravity Space 1, and Astronos's micro-geo payloads into space. And as we've mentioned before, launch is hard, and Falcon Heavy is no exception.
Stage 2 locks load is complete.
We are essentially counting down 3 rockets simultaneously, so our team is going to be conservative in case anything pops up in the last minutes of the countdown. If for some reason we do not launch today, we do have a backup opportunity tomorrow at the same time.
To be clear, they're at the edge of their
With LOX
launch
loading
window.
complete on the second stage, the Falcon Heavy is now fully loaded with 2.8 million pounds of propellant. We should see some white clouds venting from the transporter erector LOX line in just a few seconds. This is completely normal and part of our closeout process.
Ground gas closeouts.
Following that, at T-minus 1 minute, the vehicle will enter startup. This is when the onboard flight computers take over control of the countdown. Shortly after startup, we should get a call out from our LD or launch director giving the final go for launch. So let's listen into the nets for those call outs.
This is also the same launch pad that they launch the people from. You can see the tower there where they load the astronauts.
Falcon Heavy is in startup.
Great news there, folks.
Oh, that's an abort
As you
condition.
may have heard, there was an abort just called.
Crap.
over the nets. Just give us a few moments. We're going to check in with the team and listen to the nets, and we'll see if we can get some additional information to share.
Yeah, so that's an abort. That will definitely be a recycle for tomorrow. Unfortunately, yeah, they were right at the edge of their launch window, so they can't actually recycle this today, unfortunately. Ah, this is too bad. We waited all this time. Yeah, have a good night, Atharva. Okay, they're cycling back to 15 minutes. This is weird. I don't think they have launch window for this. Huh, I wonder if they'll actually recycle. Wait a second. Do they have more? Maybe they have more of a window than I thought they have. Hey, the 57-minute launch window that started 57 minutes ago. I don't think they can recycle this. Why do they put the clock back to 15 minutes? That's kind of weird.
If you're just joining us, you might notice that the clock is paused right now. We did just have an abort called out on the nets. We are waiting for some more information to provide an update, so we'll be sure to get that update to you as soon as we can.
So when the abort gets called at 59 seconds like that, it's usually because of the computer. So basically after T-minus 1 minute, the control of the vehicle basically gets transferred to the avionics on the rocket. So that's what called the abort. It wasn't a human saying like, oh, something's out of range, abort. So basically anything could be wrong. Typically it's, something to do with pressures and, engines and stuff like this. And sometimes you just have to reset the system, and sometimes the air is really easy to clear out. But I don't think they have the opportunity to recycle today, but it seems as if they're still teasing us with the opportunity that they might, which is a bit strange. Huh. Maybe they put something on Twitter? I doubt it, not that quickly.
If you are just joining us, you will notice that the clock is stopped. We did have a abort called at T-minus 59 seconds. We're just waiting for some additional information from the teams to provide everyone with an update. The vehicle and payload remain healthy, and we will provide an update as soon as possible.
I find this very strange that they're still putting the clock to minus 15. I would have thought their launch window had expired. But maybe I'm wrong. Okay. This rocket is a bit of a tumultuous beast. I think the ash and the black booster and the white booster kind of look really strange together. It almost looks like a cool paint job, except for the weird spots where the landing legs should be. Just to remind for anyone who's just joining, this is the Falcon Heavy launch now that we're looking at. We had a hold that was called at T-minus 59 seconds, and the clock was cycled back to T-minus 15 minutes. Now, the rocket was at the edge of its launch window, so I'm not really sure why it is still cycled back to minus 15 minutes. They should be recycling to tomorrow, but we're still waiting for information.
We did call an abort at T-minus 59 seconds. The vehicle and payload remain healthy. Keep in mind the purpose of the countdown is to help us catch potential issues prior to flight. There are thousands of ways to launch a rocket, and there's only one way that it can go right. Given that, we are overly cautious on the ground, and if the team or vehicle sees anything that just looks even slightly off, they will stop the countdown. Again, the vehicle and payload are in good health, but this will end our launch attempt for today. The next launch opportunity is tomorrow at 8:26 p.m. Eastern Time. Hopefully you'll all join us. Thank you for joining us today, and we will see you next time.
Looks like that's it for today, guys. So, yeah, glad that you could join us for what could have been a doubleheader, but unfortunately turned into just a single rocket launch. C'est la vie. We will try and stream the Falcon 9. Correction. We will try to stream the Falcon Heavy launch tomorrow. So hopefully we'll get a chance to see that tomorrow evening instead. In the meantime, make sure to keep expanding your horizons.